Hi, my dear students. Welcome back to my class. So today I'm back with the day 19 crash course for the lesson periodic classification of elements. So we have successfully completed 18 days of the crash courses, children. That is for biology, chemistry, and few of the physics lessons are also completed. So I once again welcome back you all to the day 19 crash course, where today I am teaching the periodic classification of elements lesson. So this lesson I'm going to teach you in today's crash course, and based on this particular lesson in tomorrow's class, I will be discussing the frequently asked question or the most important questions in the examination. Very good morning to each and everyone who are present here. So dear students, if you're new to my channel, I would like to say that please subscribe to my channel, and also do inform your friends and also your juniors to follow my channel so that I will be helping them throughout their class 10 journey. So most of you are here. Very good. Most of you are here in the morning class. I hope yesterday's carbon and its compounds lesson completely, whatever I have explained, so you all have clearly understood. So there is no doubt in previous day's crash course class. So today I'm starting with the periodic classification of elements, dear students. Yes. So dear students, when I talk about periodic classification of elements, so good morning to everyone who are present in today's class. Good morning. Okay, many are there. Very good morning to each and everyone. Yes. So when I talk about periodic classification of elements, dear students, the total weightage for this particular lesson is 4 mark. Okay. So for 4 mark, the questions are being arised for this from this particular lesson in your examination. So if we look at the both, the model question paper as well as the state level preparatory question paper. If you look at both the question paper, so from this particular lesson, so 4 marks questions are being asked. And this is a very simple lesson, dear students. It is not, there is not much things to learn from this particular lesson. Very less content is there, but that content is very important. So to understand the content is very important when I talk about this particular lesson. Okay. So without wasting much time, let me start today's class. So when I talk about, elements, so totally there are 118 elements are there. Okay. Totally at present I'm talking. At present there are totally 118 elements are there, dear students. Out of 118 elements, 94 elements are existed in the nature. Okay. Out of 118 elements, 94 elements are present in the nature only. So remaining 24 elements, so they are synthetic. That means they are prepared at the laboratory. Understood? So this is the one basic thing you have to understand. Totally 118 elements are there. Out of 118 elements, 94 are naturally occurring and 24 are synthetic. They are manufactured at the laboratory. Understand? So then the lesson says periodicity. Periodic means periodic reoccurrence of the properties. So we are understanding about the periodic classification of elements. Why do we have to classify the elements? You have to know, dear students. See, we are going to classify the elements in such a way. It has to become easy for us to understand, because it is not easy for us to remember all the 118 elements individually, their properties, their physical properties or their chemical properties. So everything, it is not possible for us to understand. ಎಲ್ಲವನ್ನ ಕೂಡ ನಾವು ಡಿಟೇಲ್ ಆಗಿ ಒಂದೊಂದೇ ಎಲಿಮೆಂಟ್ ಇಂದ ನಾವು ತಿಳ್ಕೊಳ್ಳೋಕೆ ಬರಲ್ಲ. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ? ಸೊ 118 ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ ಅಲ್ವಾ? ಈ 118 ಎಲಿಮೆಂಟ್ಸ್ ಕಂಪ್ಲೀಟ್ ಆಗಿ ನಾವು ಈಚ್ ಅಂಡ್ ಎವ್ರಿ ಎಲಿಮೆಂಟ್ ನ ಕೂಡ ನಾವು ತಿಳ್ಕೊಳ್ಳೋಕೆ ಕಷ್ಟ ಆಗುತ್ತೆ. ಸೊ what the scientists have done is, so they have classified the elements based on few elements having the similar properties. So in the group or period. So we are going to classify the elements, and we are knowing about the classification of elements based on their physical and also the chemical properties. ಅರ್ಥ ಆಗ್ತಿದಲ್ವಾ? So that is why we are going to understand about this particular lesson. ಸೊ ಈ ಲೆಸನ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿ ತಿಳ್ಕೊಳ್ಬೇಕಾಗಿರುವಂತ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ನಾನು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಬರ್ತೀನಿ. ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ದಿ ಫಸ್ಟ್ ಅಂಡ್ most importantly, the one thing which you have to focus here for 1 mark, first 1 mark ಒಂದು ಕ್ವಶನ್ ಕೇಳ್ಬೋದು ಇದರಲ್ಲಿ, ಅಂಡ್ 3 mark ಒಂದು ಕ್ವಶನ್ ಕೇಳುವಂತ ಚಾನ್ಸಸ್ ತುಂಬಾ ಇರುತ್ತೆ. ಟೋಟಲಿ ನಾನು ಹೇಳಿದೆ ಇದಕ್ಕೆ ವೇಟೇಜ್ ಬಂದು 4 mark ಇದೆ. ಸೊ ಔಟ್ ಆಫ್ 4 mark ಅಲ್ಲಿ ಒಂದು 1 mark ಕ್ವಶನ್ ಕೇಳ್ಬೋದು ಅಂಡ್ 3 mark. ಈ 1 mark MCQ ಆದ್ರೂ ಆಗಿರ್ಬೋದು ಅಥವಾ 1 mark ಕ್ವಶನ್ ಕೂಡ ಆಗಿರ್ಬೋದು. ಓಕೆನಾ? ಸೊ ಫಸ್ಟ್ಲಿ ವಾಟ್ ಯು ಹ್ಯಾವ್ ಟು ಡೂ is you have to focus on the 4 laws. You have to focus on the 4 laws. Okay, so which are the 4 laws here? The 4 laws present in this particular lesson is, first one is Döbereiner triad law, second one is Newlands law of octaves, third one is Mendeleev's periodic law, fourth one is modern periodic law. All the 4 laws you have to understand, dear students. So today, in today's class, I'm going to explain about all these laws. So very good morning to each and everyone who are present in today's class. So today many participants are there. So yes, fine. So let me continue the class. See, when I talk about Döbereiner triads, children, when I talk about Döbereiner triad law andre enu? Triad andre gumpu. So it is a group. So tri means 3. That means it is a group of 3. Understand? Triad means it's a group of 3. That means we can say 3 groups. Artha agtidya? We can say 3 groups. So here, when I say Döbereiner's triad, what do Döbereiner triad say? See, according to Döbereiner triad, when the elements were arranged in the increasing order of atomic mass, when the elements were arranged in the increasing order of atomic mass in the group of 3 elements, you know, which is having the similar chemical properties, okay, we have observed something. What we have observed? See, according to Döbereiner triad law, what do Döbereiner triad law say? I am giving more focus on what you have to learn with respect to examination point of view. Artha agtidya? What you have to learn with respect to examination point of view, I am teaching you. Okay, see, in exam Döbereiner, if you have to write Döbereiner, it is Dobereiner. Okay, Dobereiner. It is correct. Döbereiner's triad law spelling is correct. Yes, fine. So now, I was telling you according to Döbereiner triad law. So what do this law says? This law says that the atomic mass of the middle element of the triad was roughly average of the atomic mass of the other 2 elements. This is very important law, dear students. See, for 1 mark they can ask in the examination. For 1 mark they can ask in the examination. Okay, so how can we justify this law? See, they are saying atomic mass of middle element in the triad is roughly average to the atomic mass of other 2 elements. See, this is a triad. Now this is a triad, you can see. In this triad, see, there are 3 elements. The atomic mass of middle element, for example, this is a middle element. Okay, the atomic mass of this middle element is roughly the average of the atomic mass of other 2 elements. How do you identify? See, average of atomic mass, for example, the first and third element. See, now calciums. Okay, let me write the mass of calcium. Okay, what is the mass of calcium here? You can observe. The mass of calcium is 40.1. It is 40.1 divided by, okay, 2. And you have to take the mass of barium, that is 137.3. Okay. So what are you going to do is you are going to add the mass of calcium and also the barium, and you will divide by 2 to know the average mass of this strontium. Okay. So when we add calcium, that is 40.1, and plus barium, that is 137.3, we will get almost 177.4. So 177.4 we get. So when we divide this by 2, when we divide 177 divided by 2, so when we divide this by 2, we get 100 and almost. So you can do it. 2 ones are 2, 6 2 sevens are 18. If 17 is there, no. So 2 ones are 2. 2 eights are 16. 2 eights are 16 you can do. And I think you can do it this. Okay. So when we divide whatever we got here, 137 plus 40 is 177.4. So 177.4 divided, if you divide by 2, you will get almost 80. Okay, again, what one's the carry? Again, carry it means 17 it will become. It means, okay, again 2 eights are. So you will get 2 eights, again 1 is remaining, 4 it will be carrying. So almost again it is 2 sevens are 40. Yes, 88.7 you will get, children. 88.7. So 88.7 is almost nearby to this strontium, that is 87.6. So that is why they are saying the atomic mass of the middle element, this middle element in the triad is roughly average. It is not exactly same. It is average to the atomic mass of other two elements. Very important, dear students. Okay. So once again I say, see, the atomic mass of middle element in the triad is roughly average of the atomic mass of the other two elements. Dear students, in the examination they can ask you like this. They can give you the atomic mass of the two elements, and also they can ask you to find out the atomic mass of middle element. They can ask like this. See, the atomic mass of element A, element B and element C in the triad are given. See, element A's atomic number, for example, the atomic mass of element A is 20 and the atomic mass of element C is 30. Okay, let us write 30. Okay, and we don't know what is the atomic mass of element B. So you have to identify the atomic mass. They will ask, how do you do it? You just take these two. Okay, 20 plus 30 you make it. 20 plus 30 you make it. So 20 plus 30, after writing 20 plus 30, you have to divide by 2. Okay. So when you make 20 plus 30, what you get? You get 50. So 50 divided by 2. 50 divided by 2. Again you get 2 ones are. 2 twos are 4. And if you carry 1, it will become 10. Then it is 2 twos are, no, I have written 4s are, sorry. So it is 2 twos are 4. 2 twos are 4. If we carry 1, it will become 10. So again it is 2 fives are 10. So the mass of the middle element is 25. Okay. So like this you have to identify in the examination. Okay. So in this way they ask you in the examination, dear students. It is very important to know the Döbereiner's triad law and also how to identify the mass according to the Döbereiner's triad law. It is very important. Okay. So what do the Döbereiner triad law says? The atomic mass of middle element is roughly the average of atomic mass of other two elements. You have to learn this compulsorily. So for 1 mark they can ask in the examination. It is very important, dear students. Yes. So moving to next, see, when we talk about Döbereiner triad law, children. So as I told you, see, according to Döbereiner triad law, not all the elements was following his triad law. Okay. Not all the elements was following the triad law. That means it was not that is following that atomic mass of middle element was roughly the average of atomic mass of middle element. That is, it was not, every element was not followed by the, was not following the Döbereiner's triad law. So that is why there are some limitations in Döbereiner triad law. So what are the limitations? See, when we look at the Döbereiner triad law limitations, see, only 3 triads were recognized from the elements known at that time. Okay. So there were only few elements during the Döbereiner period. Okay. So when we look at those elements, out of all those elements, only 9 elements was following the Döbereiner triad law. 9 elements is nothing but the 3 triad, dear students. 9 elements is nothing but the 3 triad. Okay. Only 9 elements, that is nothing but 3 triads were following the Döbereiner triad law. So that is why there is some limitation in Döbereiner triad law. Understand? Because not all the elements were following his law. So when we look at in examination, see, they can ask any triad from the textbook. In your textbook, there are 3 triad given. So one is they have given lithium, sodium and potassium, calcium, strontium and barium, chlorine, bromine and iodine. These 3 triads are given in the textbook. So they may give the mass of these 3 because in table 5.1 it is given. Okay. So let us take the one more. If we take, okay, now let us take this calcium. If we take this one, see the atomic mass of calcium, I think we have already did this. Let me take one more. Okay. The atomic mass of chlorine, let us take. Atomic mass of chlorine is 35.5. Okay, 35.5 is the atomic mass of chlorine. Atomic mass of iodine. Atomic mass of iodine is 126, dear students. 126.9. They will only give the mass. Okay. So you have to find out the middle one they will ask. And you also want to tell whether this is following the Döbereiner triad law. Anta kelbodu. So what will you do? You will add these two. 35.5 plus 126.9 you will do. Okay. 35.5 plus 126.9 you will do, and you will divide by 2. Okay. So when you make 35.5 plus 126.9, so the sum will be almost, yeah, it is 162.4. Okay. So 162.4 the answer you get. So you have to divide this by 2. So when you divide this by 2, okay, almost you will get 81.2. You will get 81.2. You can divide and check. You will get 81.2. So 2 ones are 2, 8s are 16. Okay. Again you will get 2 ones are 2. Point again 2 2s are 4. You get 81.2. Okay. So what is the mass of bromine? Bromine is almost 79.9. So it is close to 81.2. That is the reason this is following the triad law. Okay, I told you it is the average mass of the other two elements, not exactly same. Understand? So bromine's mass will be almost close to the 81.2. So, but in textbook they have given the mass of the bromine is 79.9. So this is always following the now Döbereiner triad law. So you want to understand this, dear students. It is very important to know what is meant by Döbereiner triad law. According to Döbereiner triad law, how to find out the mass of the middle element. Very simple. So just add first elements and last elements mass, divide by 2. You will get the middle element's average mass. Okay. Very important. So let us now move towards the next one, children. That is the Newlands law of octaves. The second law is Newlands law. Very important. Okay. Yes. So when I talk about Newlands law of octaves, dear students, see, Newland arranged then known elements in the order of increasing atomic mass. So when the Newland was there, I think you have seen about the Newlands law in the textbook. So during Newland's time, there was only 56 elements. Okay, there were 56 elements during the Newland's period. So whatever the 56 elements were there, so what Newland did? Newland has taken all the 56 elements. Then he arranged those elements in the increasing atomic masses. When he arranged the elements in the increasing atomic masses, he found that the properties of the every eighth element is similar to that of first one. I'll tell you how we can identify this. So when Newland arranged then known 56 elements in the order of increasing atomic mass, what Newland found? Newland gain gotaitu andre. So Newland gain observe marda, the properties of eighth element was similar to that of first element. So eighth element na property hagu first element na property similar agirodana avanu observe marda. Okay na? So that is what the Newland's law of octave says. Octa andre eighth anta artha. Oct means 8. Okay. So in examination, if they ask you to write the state Newland's law of octaves, what do you write? You write this. The properties of every eighth element is similar to that of first element according to Newland's law of octaves. You're going to write this in the examination to get 1 mark, dear students. And he also compared to the octaves found in the music. So after finding out this, he has compared this to the octaves found in the music. See, when we look at the music notes, sa, re, ga, ma, pa, da, ni. So you can see 1, 2, 3, 4, 5, 6, 7. Again for 8, we are getting sa. Correct. So the first and also when we come back again 8, the first and 8th elements are similar. Understand? They have similar properties. Understood? So that is the reason he has compared his law to the octaves which is found in the music. That is why he has given the law called as law of octaves. In examination, they can ask you either to write Newland's law or they can ask law of octaves. Both are same, children. Erudukku kuda same answer baritira. Understand? You will write same answer for both. Yes. Fine. So now let us understand, children, whatever your doubts is there, I will be clarifying at the end of the class, okay? Or in between, I'll just take a break and I will let you know. So please now understand the topics which I'm explaining to you now. Yes. So now, Newlands law of octaves, law you have to write this. Law of octaves means you will write the same law. See, for example, let us check the periodic table of Newlands, okay? So when we look at the periodic table of Newlands, you can check out, children. So this is how the periodic table of Newlands look. So you can see the music notes are given here, sa, re, ga, ma, pa, da, ni, sa. And also you can check. See, the first element is hydrogen, followed by second lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Okay, so now first element is the hydrogen and the eighth element is the fluorine, which is in the same group. So the first element hydrogen and eighth element fluorine have the similar properties. I am saying, dear students, a similarity I am telling. I am not telling you exactly. I am not telling you exactly. It is similar. Okay, so in the examination they can ask you, which are the two elements? If we start from hydrogen, next element, which is the next element which is similar to that of hydrogen, which is having the similar property of hydrogen, they can ask. So the eighth element is fluorine. If we start from lithium, lithium will be the first element. So next, second, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and also sodium will be the eighth element. So lithium and sodium are kept in same group because they have similar property. Again, when we start from beryllium, so when it comes to magnesium, see 1, 2, 3, 4, 5, 6, 7, 8. Eighth element is magnesium. So beryllium is the first element, eighth element is the magnesium. They have similar property, similar to that of boron and aluminium also. First, when we start from boron, it will end at aluminium as an eighth element. So boron and aluminium are also having similar property. So like this, when the elements are arranged in the increasing order of their atomic mass in the Newlands periodic table, he has observed that the first elements and eighth elements properties are similar. That is what he exactly observed in his table, dear students. Okay, fine. But this, whatever his law is there, it was not applicable for all the elements in his periodic table. That is the reason there are some limitations in the periodic table of Newlands. Very important, dear students, in the examination they will ask you, write the limitations of Newlands periodic table. Write the limitations of Newlands periodic table. They will ask in the examination. Someone is asking about sources of energy notes. Okay, fine. If you have not got the notes, I will share in the Telegram group. Okay, fine. So in the examination, they will ask you what is meant by Newlands law. They can ask for 1 mark. You will write. What do you write? You write the properties of elements are, the properties of every eighth element or the similar to that of first element. You will write according to Newlands law. And when we look at Newlands law, there are few limitations, dear students. I will tell you what are the limitations. Check. You can observe. See, when we look at Newlands periodic table, this Newlands law was applicable only up to calcium. That means up to calcium, every first element and eighth element was following his law. That means they were having the similar properties. So it was found that the law of octaves was only applicable up to calcium. Understand? After calcium, whatever the elements which are present here, chromium or titanium or manganese or iron, so these were not following the Newlands law of octaves. Very important. And second, that is limitation is, see, it was assumed that Newland thought that there was only 56 elements in the nature and no more elements will be discovered in the future. ಅವನು ಅನ್ಕೊಂಡಿದ್ದ ಮುಂದಕ್ಕೆ ಯಾವುದು ಎಲಿಮೆಂಟ್ಸ್ ಡಿಸ್ಕವರ್ ಆಗಲ್ಲ. 56 ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ ಈಗ, 56 ಎಲಿಮೆಂಟ್ಸ್ ಇರುತ್ತೆ, ಮುಂದಕ್ಕೆ ಯಾವುದು ಎಲಿಮೆಂಟ್ಸ್ ಡಿಸ್ಕವರ್ ಆಗೋದಿಲ್ಲ ಅಂತ ಅವನು ಡಿಸೈಡ್ ಮಾಡ್ಕೊಂಡಿದ್ದ. So that is one of the limitation. It was a wrong assumption. And see, in order to fit the elements in his table, Newland adjusted 2 elements in the same slot. ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು ನೋಡಿ, ಒಂದು ಎಲಿಮೆಂಟ್ ಒಂದು ಸ್ಲಾಟ್ ಅಲ್ಲಿ ಇರಬೇಕು, ಒಂದು ಸ್ಲಾಟ್ ಅಲ್ಲಿ ಒಂದೇ ಎಲಿಮೆಂಟ್ ಇರಬೇಕು. ಬಟ್ ನ್ಯೂಲ್ಯಾಂಡ್ ಏನ್ ಮಾಡಿದ್ರು, ಅಡ್ಜಸ್ಟ್ ಮಾಡಕ್ಕೆ ಎಲಿಮೆಂಟ್ಸ್ ನ ಅಡ್ಜಸ್ಟ್ ಮಾಡಕ್ಕೋಸ್ಕರ, ಇನ್ ಆರ್ಡರ್ ಟು ಅಡ್ಜಸ್ಟ್ ದ ಎಲಿಮೆಂಟ್ಸ್, he has adjusted 2 elements in same slot. This is the wrong order of arrangement. So this is also one of the limitation. Okay, and the cobalt, nickel, and also the iron, these 3 elements were having the similar property. Understand? Cobalt and cobalt, nickel, and iron. So all these things, excuse me, dear students. So here what we can observe here is, see, the elements which are having similar properties were arranged in the different groups. That is the next, the limitation. Very importantly, you want to understand. See, the cobalt column as fluorine and chlorine. See here, fluorine, chlorine, bromine, they were not having the similar property to that of cobalt and nickel. Cobalt and nickel was having the property similar to that of iron. Understand? Then these three elements, cobalt, nickel, and iron, and now one day group idbekittu. But what Newland did was, he has arranged in the separate group. That is a wrong order of arrangement, because hydrogen, fluorine, chlorine was not having the property similar to that of cobalt and nickel. Okay, so that is the one more limitation I can say. Okay, so these are all the limitations that we can see when we look at the Newlands periodic table, dear students. Understand? So very importantly, you have to note down all the limitations. See, the limitations only can be asked for 3 marks. 3 marks ke limitations ne keluvanta chances irutte. Athwa 2 marks ku kuda limitations na kelbahudu. Understand? So it is very important, you have to note down all the things. Yes. Fine. So once again, if you want, I'll explain this. Do you want me to explain the limitations of Newland once again? Do you want me to explain the limitations of Newland once again? If you are clear with this, let me move forward. Shall I move forward? Specify. Shall I move forward? Okay, fine. So someone is asking, ma'am, which is the most reactive metal? Actually, most reactive metal, if you ask me, you want to give certain elements. So if, for example, if calcium, magnesium, iron, sodium, potassium, if they ask like that in the examination, okay, so the most reactive element there is sodium and potassium. So if they give certain elements and ask which is the most reactive element, you can answer which is the most reactive element. Okay, those who want me to explain once again, quickly I will explain. The students who are now already understood, it's again one more revision for you. Please stay back. Okay, fine. See, according to Newland's law of octaves, children, so every 8 element has a property similar to that of first one. Okay, and when we look at the Newland's periodic table, so his law was not applicable to all the elements in his periodic table. There was few limitations. So that limitations, we will call it as Newland's limitation. In the examination, they will ask, what is the first limitation? See, according to Newland's law, the law was applicable only up to calcium. That means every 8th element was similar to that of first one. So that law was only applicable up to calcium. So secondly, Newland thought that there was only 56 elements were there in the nature. So no more elements will be discovered in the future. It was wrong assumption. Later, so many elements were discovered. Okay. And see, in order to adjust the elements, the Newland has kept 2 elements in same slot. This is the wrong order of arrangement. And cobalt, nickel, and iron having similar property were arranged in the different group. Because hydrogen, fluorine, and chlorine was having the property different from cobalt and nickel, they were kept in same group. This is also wrong order. So all these are the limitations of Newland. Okay, I think you are clear with this, students. So let me move forward to explain whatever the points I have explained now. So all these points are here only. Okay. When I share the notes, you can read them. So I told about all the points which I have mentioned here. So moving to next, we are moving for next one, dear students, that is Mendeleev's periodic table. Okay. As there was some limitation in Newland's periodic table, scientists have come up with the few more things, few more changes. So even they have come up with the few more changes, they have come up with the next periodic table, that is the Mendeleev's periodic table. See, in examination, only limitations they will ask. They will ask only limitations of Newland's periodic table. Okay, so do note down. So if anything extra has to be taught, definitely I will teach you. Okay, so with respect to examination point of view, I'm telling only limitations are asked. Yes. So now let us talk about Mendeleev's periodic table. Dear students, when I talk about Mendeleev's periodic table, okay, so this periodic table was all completely based on the atomic mass. So it was completely based on the atomic mass. Okay. See, according to Mendeleev's periodic table, when the elements were arranged in the order of increasing atomic mass, the element with the similar properties occur at regular intervals. That means which were having the similar properties was repeatedly occurring. Understood? So by looking at this particular thing, Mendeleev have arrived with one of the law. What is that law? See, the properties of the elements are the periodic functions of their atomic mass. I am explaining only with respect to examination point of view, dear students. Understand? Yes. So someone is asking about Döbereiner triad law mathematically. Yes, I will explain you at the end of the class. Please stay back. Okay. Yes. According to Mendeleev's periodic law, the properties of the elements are the periodic functions of their atomic masses, dear student. Actually, one thing I would like to tell you. Mendeleev periodic table nalli elements na arrange ಮಾಡಬೇಕಾದ್ರೆ mass ನ ಪ್ರಕಾರ arrange ಮಾಡಿರಲಿಲ್ಲ. But arrange ಮಾಡಿದ್ಮೇಲೆ it was according to the increasing order of atomic mass. He observed that elements were there according to the increasing order of atomic mass. Okay. So by looking at that, and also he has observed the periodicity. Periodicity means reoccurrence of some of the properties of the elements. He observed that. So by looking at that, Mendel have arrived with the principle. He has arrived with the law called as the properties of the elements or the periodic functions of their atomic masses. So this is the Mendeleev's periodic law. This is the Mendeleev's periodic law. So this Mendeleev's periodic law was completely based on the chemical properties, dear students. It was completely based on the chemical properties. I'll tell you how and why. Okay, so what Mendeleev did was, whatever the elements which were there during his period, no, he has taken all the elements and he made it to react with both hydrogen as well as oxygen. Why only with hydrogen and oxygen? Because they are the elements which can easily react with all the other elements. Hydrogen and oxygen can readily react with other elements. That is the reason Mendel have reacted the elements along with the hydrogen and also the oxygen. So we call it as hydrates and oxides. Okay, that is why I say his periodic table was based on the chemical properties. On the basis of chemical properties, the Mendeleev has arranged the element in his periodic table, and when he arranged the element, he found that they were in the increasing order of atomic masses. Understood? So then he gave this law called as Mendeleev's periodic law. So let me tell you how the chemical properties were seen in the Mendeleev periodic law. Yes, dear students. See, when we look at the Mendeleev's periodic table, see, I told you that. So he has reacted the elements with both the oxygen and also the hydrogen. So we call it as oxides and also the hydride. These were some of the general formulas which is given in the, the periodic table. In the examination, what kind of questions they can ask? They can ask, okay, when hydrogen is readily reacted with the oxide and hydride of the, the Mendeleev periodic table, what kind of formula can be obtained? See, when hydrogen, this is present in the first group. When hydrogen is readily reacting with the oxygen and hydrogen, what kind of the formula can be obtained? Look at this. One is R2O. Oxide is in the R2O form. Hydride is in the RH form. So when hydrogen is written in this oxide and hydride form, see H2O. R is nothing but here the elements. Okay. R is nothing but elements in the periodic table. Understand? O and H are the oxide and the hydride. So H, when we written in the R2O form, as I told you, R is nothing but the element. R2 is nothing but H2. So O you will write as it is as oxide. Okay. R2O is nothing but H2O. Similarly, when we write it as hydride, so R is nothing but H and one more H is there. So H plus H we can get again H2 we will get. We will write it as H2. I'll give you one more example. See, when I write Li to R2O form, so R is nothing but Li. So R2O is nothing but Li2O. So just you have to write the chemical form. Okay. Next, when I write RH, that is LiH, that is the hydride of lithium. It is the hydride of lithium. This is the hydride of oxide. That is oxide of lithium. Okay, oxide of lithium, hydride of lithium. So anything that can be asked in the examination, dear students. They will give the oxide and hydrate formulas, and they will ask you to write the elements in their respective oxide and hydrate formula. Let me give you one example. Let me now take the third group. Okay, when I take third group, so the element is now boron. Okay, so R2O3, that means B is nothing but R. R2O3 is nothing but it is B2O3. So this B2O3 is the oxide of the boron. It is the oxide of the boron. Similarly, when I write the hydrate form of this boron, it is RH3. R is nothing but boron again. So it is BH3. BH3 is the hydrate of boron. So they don't ask you name here. They are asking only to write their chemical forms. Okay, because Mendel has arranged the elements based on their chemical properties. He has taken all the elements and he readily reacted with reacted every element with both the oxygen and also the hydrogen, and he got the respective hydrates and also the oxides, dear students. So when he got respective hydrates and oxides, this was written in this form. Understood? And one more example, if I would like to give, see, let us take F, fluorine. So it is R2O7. Let us write now F2O7. R is nothing but F. R is nothing but the elements present in the group. F2O7 is the oxide of the fluorine. Understand? So like that, you can take any element and react with this oxides and hydrogen to get the respective chemical formulas. Okay, I think you are clear with this. Understood? I think you are clear with this, dear students. Let me ask you a question now. Okay, so if I take the sixth group, okay, so what is the oxide of oxygen? What is the oxide of oxygen? Who will answer first? What will be the oxide of oxygen? What will be the oxide of oxygen? So let me see who will answer first. What is the oxide of oxygen? Just multiply RO3 to O. Very good. Tulasi has given the right answer. Followed by, nobody has given, only she has given right answer. Yes, children. See, RO3 is there. RO2 is there. R is nothing but O. O plus O2 is giving rise to O3. Okay. Yes. Similarly, when I write RH2, it is OH2. It is OH2. You are just multiplying to this whatever the respective oxide and also the hydride which is given here. Okay, very important, dear students. Yes, I think this is clear now. So let me now move towards some of the merits and also the disadvantages of the Mendeleev's periodic table, because in the examination they also ask you the merits. When it comes to Mendeleev periodic table, they will ask merits. But when it comes to Newlands periodic table, they will ask you only the limitations of Newlands periodic table. Very importantly, you want to understand. Okay. So now when I talk about the merits, of Mendeleev's periodic table, see, there were some gaps which were left in the Mendeleev's periodic table for the undiscovered elements. Mendeleev left some of the gaps for the undiscovered elements. Okay. So there are examples which were the undiscovered elements, for example, gallium, scandium, and also the germanium. So if you look at a textbook in page number 28, they have given. Okay. So he has, given some of the name for some of the elements. For example, see the undiscovered element so-called gallium. So he has left the gap for this, and he also called that in future one of the element can be discovered by the name Eka aluminium, and he also has given the mass for this. So the mass would be the 68. Okay, mass would be the 68. But in future, what happened? The Eka aluminium, that is the whatever the predicted element by the Mendeleev, has been discovered in the future as a gallium. Understood? So this was one of the great achievements by the Mendel. So some of the gaps which were left in the Mendeleev's periodic table for the undiscovered element were discovered in the future. Future earlier to discover I2. Mendeleev has left the gap for gallium which was discovering in the future. Okay. So he has given the name for the gallium as Eka aluminium. So he also told that the mass would be 68 for this particular element. But in future, one of the element by the name gallium was discovered with the atomic mass 69.7. Okay, the gallium was having the atomic mass 69.7. Understood? So this was one of the great achievement by the Mendeleev. And he also predicted that the properties of the elements were based on their positions in the periodic table. This is also one of the achievements. And he accommodated noble gases when they weren't discovered without disturbing in the original arrangement. So he accommodated all the noble gases when they were discovered without disturbing the original arrangement. That means already there were few elements in his table. Okay. When the noble gases were discovered, he has given the place for the noble gases without disturbing the elements which are already existing in the order. So that was also one of the great achievement by the, the Mendel. So very importantly, you want to understand, dear students, all these are very important, because when they asked about the merits of Mendeleev's periodic table, you want to note down all these merits are very, very important. I have mentioned in a very simple way here. Okay. If you write in this form, we will definitely give marks in the examination. Okay. Yes. So first and foremost, I'll just repeat it. First merit is some gaps were left, which were for the undiscovered elements, okay, by the Mendeleev. So the undiscovered elements were discovered in the future as gallium, scandium, and germanium. Okay. For this particular element, the Mendeleev has given, especially for the gallium, the Mendeleev has given the name called Eka aluminium. It was discovered in future. And so he has predicted the properties of elements on the basis of their positions in the periodic table. And also he accommodated the noble gases. So when they were discovered, when the noble gases were discovered, he accommodated the noble gases without disturbing the original arrangement. Without disturbing the original arrangement, he accommodated the noble gases. Yes, very good, dear students. So now let me tell you about the limitations of Mendeleev's periodic table. So there were few limitations in the Mendeleev's periodic table. What were those limitations? See, I told you the Mendeleev's periodic table was based on the atomic mass and also chemical properties. So when the elements were arranged in the increasing order of atomic mass, okay, so he could not give the position for the few things. So let me tell you what are those things. See, first of all, position of isotopes could not be explained. So position of isotopes could not be explained. I think you know about isotopes. You have learned in the class 9. Okay. So what is meant by isotopes? Isotopes is nothing but they are having the same atomic number, different mass number. As the Mendeleev's periodic table was based on the mass number. For example, if the hydrogen is having the atomic mass 1, 2 and 3, because hydrogen is an isotope. Okay. Hydrogen, carbon, they are all isotopes. Okay. Hydrogen has 3 masses. That is atomic mass with 1, atomic mass with 2, atomic mass with 3. So now as it is having 3 atomic mass, he could not give the 3 places for that particular isotopes. So position of isotopes could not be explained. And there was no fixed position for hydrogen. Why? Because as I told you, hydrogen has 3 masses. So he could not give the fixed position for isotope and also the hydrogen. Even hydrogen is also an isotope. And there were wrong order of atomic masses seen. That means when we look at his table, see, I'll show you his table. When we look at the table, that is the Mendeleev's periodic table, there was wrong order of atomic masses. See, when we look at here, you can observe here, cobalt and nickel. I told you that the table was based on the increasing order of atomic mass. You can observe 29, 28. So whatever you are observing here, so it was, based on the increasing order of atomic masses. But if you see in this one particular slot, okay, cobalt and nickel you can observe. See, cobalt with the atomic mass 58.93 and nickel with the atomic mass 58.71. So cobalt was having the more atomic mass compared to nickel. So cobalt has to come next, but nickel has to come first. But what you can observe here is the atomic mass with the higher number was arranged first than the lower number which was arranged next. Okay, this was the wrong order of arrangement. So the atomic, here the third limitation is wrong order of arrangement was seen. What arrangement? Atomic mass. Wrong order of atomic mass arrangement was seen in the Mendeleev's periodic table. Very important, dear student. This is also one of the limitations. Okay. Wrong order of atomic masses of some elements could be seen and they could not be explained. Okay. He could not explain the wrong order of arrangement in his periodic table. Okay. So these were some of the important limitations that you are going to write in the examination. If they ask for 3 marks also, for 3 marks you'll write only these 3 points. Okay. So in exam, nimage ಅನಿಸಬಹುದು ಈ 3 points ಬರೆದ್ರೆ 3 marks ಕೊಡ್ತಾರಾ? So essay writing ತರ paragraph ಐತರ ನಾವು ಆನ್ಸರ್ ಬರಿಬೇಕಾಗಿಲ್ವಾ? No need to write the answers like essay writing or paragraph. Okay. Only they are asking the limitations. There are 3 limitations. So if you write 3 limitations, you will get 3 full marks. You will get 3 full marks. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ? ಸೊ ಪೊಸಿಷನ್ ಆಫ್ ಐಸೋಟೋಪ್ could not be explained. There was no fixed position for hydrogen and there was a wrong order of atomic mass of seen in some elements and that could not be explained by the Mendel. So these are the limitations of Mendeleev's periodic table, dear students. Okay, this is very, very important. Yes. So somebody is asking, ma'am, screen is blurred. Please check out your video resolution. Keep it for 480 pixels in the settings. Yes. Moving to next, children. See, when there was some limitations. See, there was some limitation in this periodic table. To overcome this limitation, okay, then the other person by the name Henry Moseley has come up with the modern periodic table. So Henry Moseley has arrived with the modern periodic table. Why? Because there was some limitations in the Mendeleev periodic table. So to overcome this problem, the modern periodic table has came to existence. And this periodic table is been given by the person by the name Henry Moseley. ನಿಮ್ಮ exam ಅಲ್ಲಿ ಕೇಳಬಹುದು, write the Henry Moseley's periodic law. So what is Henry Moseley's periodic law? The Henry Moseley's periodic law is same as the modern periodic law. So ಏನ್ ಹೇಳುತ್ತೆ modern periodic law? According to modern periodic law, firstly, see, this was based on, the modern periodic law was based on the atomic number. It was based on the atomic number. So according to modern periodic law, so the properties of the elements in the were the periodic functions of their atomic number. What we have said in the Mendeleev's periodic law, in Mendeleev periodic law, I told you the properties of the elements were based on the mass. But in modern periodic law, the properties of the elements are the periodic functions of their atomic number. Ali mass agittu, illi number agide. Statements are exactly same, dear students. Okay, statements are exactly same. So ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, the properties are the properties of the period, that is elements are the periodic functions of their atomic number. It is not mass, it is number. So when we look at the modern periodic table, dear students, when we look at the modern periodic table, see, in the modern periodic table we have the 18 vertical columns. We have 18 vertical columns and these 18 vertical columns were called as group. 18 vertical columns are called as groups, and we were also having 7 horizontal rows, and these 7 horizontal rows were called as periods. So 18 groups were there and 7 periods are there. 18 groups and 7 periods are there in the modern periodic table. Very important, you have to understand everything which I am saying in this class, because based on these topics only the questions will be asked in the examination. Okay, yes. See, when I talk about modern periodic table, you have to note down the important things which I tell you. So ma'am, which is the important limitation in this lesson? Both the Newlands and also Mendeleev limitations are very, very important. Both limitations are important, but when it comes to advantages, that is the merits, it is very important to understand and learn the merits of a Mendeleev's periodic table. Okay, so we will ask Mendeleev's periodic tables the merits. When it comes to limitations, both Newlands and also the Mendel's limitations are very important. Both you have to learn. Okay, yes. So I was telling you that there are 18 vertical columns called as groups and 7 horizontal rows called as periods. Okay, so this is one thing you have to learn. This is the fourth law which we are learning. The properties of the elements are the periodic functions of their atomic number. The fourth law for modern periodic table is very, very important, dear students. Okay, so this is all about the 4 laws, their limitations and their merits or demerits, whatever it is. So demerits andru onde, limitations andru onde, please note down. The demerits is same as the limitations. Yes, fine. So now let us understand the most important topic. ನಿಮ್ಗೆಲ್ಲ ಕಷ್ಟ ಆಗುವಂತ ಪೋರ್ಷನ್ ಇದು. ಬಟ್ ಯಾಕೆ ಕಷ್ಟ ಅಂತಂದ್ರೆ ನೀವು ಇದನ್ನ ಕರೆಕ್ಟ್ ಆಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಂಡಿರಲ್ಲ. So you have to understand about this particular thing, children. So now we are going to focus towards the most important topic of this lesson, that is the trends. We are going to understand the trends. So before telling about the trends, ನಾನು ನಿಮಗೆ ಹೇಳಕ್ಕೆ ಇಷ್ಟಪಡ್ತೀನಿ ಅಂದ್ರೆ you want to understand and learn the first 20 elements. So first 20 elements ಅನ್ನ ನೀವು ಕಲ್ತ್ಕೊಳ್ಬೇಕು. ಸೊ ನೋಡಿ, ಈ ರೀತಿ ಟೇಬಲ್ ನಾನು ಈಗ ಏನ್ ಬರಿತಾ ಇದ್ದೀನಿ, ಇದೇ ರೀತಿ ಟೇಬಲ್ ಅನ್ನ ನಿಮ್ಮ ಕ್ಲಾಸ್ ವರ್ಕ್ ಅಲ್ಲೋ ಅಥವಾ ಒಂದು ನೋಟ್ ಬುಕ್ ಅಲ್ಲೋ ಅಥವಾ ನಿಮ್ಮ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ನಲ್ಲೂ ನೀವು ಬರ್ಕೊಳ್ಳಿ. ಬಿಕಾಸ್ ಇಫ್ ಯು ರೈಟ್ ದಿಸ್ ಟೇಬಲ್, ಇಟ್ ಈಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ನೀವು ಯಾವುದೇ ಒಂದು ಕ್ವಶನ್ಗೂ ಕೂಡ ನಿಮ್ಮ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಆನ್ಸರ್ ಮಾಡ್ಬೋದು. ಸೊ ನಾನು ನಿಮ್ಗೆ ಹೇಳಿದೆ 18 ಗ್ರೂಪ್ಸ್ ಇದೆ, 7 ಪೀರಿಯಡ್ಸ್ ಇದೆ. ಯು ಆರ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ಲರ್ನ್ ಆಲ್ ದಿ 18 ಗ್ರೂಪ್ಸ್ ಅಂಡ್ 7 ಪೀರಿಯಡ್ಸ್. You are going to learn only few. You are going to learn the first, okay, you are going to learn the first group, and also you are going to learn the second group. Okay, after that you are going to learn the, okay, in middle there are no groups you are going to learn. We will start from, next we will start from 13th group, then you are going to learn the 14th group, then you are going to learn the 15th group, then you are going to learn the 16th group. I think the place is not sufficient here. Okay, let me write neatly. Take out. So which are the important things which you are learning for examination? I'll teach you. The first group, second group, third group, not third group, it is 13th group. Okay, I'll take out this. Okay. In the middle, you are not going to learn anything. We'll start from 13th group, 14th group, 15th group, 16th group, 17th group, 18th group. Okay, these many groups you will learn. And how many periods you learn? You will learn first period, you learn second period, you learn third period, and you will also learn fourth period. So ಇದಕ್ಕೆ ಅಂತಾನೆ ಒಂದು ಸಿಂಗಲ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಗಿ ನಾನು ಮಾಡಿ ವಿಡಿಯೋ ಆಲ್ರೆಡಿ ಅಪ್ಲೋಡ್ ಮಾಡಿದ್ದೀನಿ. Okay, so these many things you will learn. And which are the elements you will learn? Firstly, we'll start with hydrogen. You will learn hydrogen, first element, helium, hydrogen, helium, then lithium, that is the third element, atomic number is 3, lithium. Then you learn beryllium, followed by boron, carbon, nitrogen, oxygen, fluorine, you learn fluorine, and also you learn neon. Okay, then 11th element, sodium, magnesium, okay, sodium, magnesium, aluminium, okay, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Okay, so this is exactly you want to write in your book and learn. And then 19th element is potassium, 20th element is calcium. Students, only so much you will learn for your exam. Istೇ ಕಲಿಬೇಕು ನಿಮ್ಮ ಎಕ್ಸಾಮ್ಗೆ ನೀವು. ಎಕ್ಸ್ಟ್ರಾ ಏನು ಬೇಡ. ಓಕೆನಾ? Only 20 elements you learn and ಇದೇ ಆರ್ಡರ್ ಅಲ್ಲಿ ಬರ್ಕೊಳ್ಳೋದನ್ನ ಕಲ್ತ್ಕೊಳ್ಳಿ. See, first element is hydrogen, followed by helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. So ಇದನ್ನ ಹೇಗೆ ನೆನಪಿಟ್ಕೊಳ್ಬೇಕು ಅಂತ ಒಂದು ವಿಡಿಯೋನ ಆಲ್ರೆಡಿ ನಾನು ಅಪ್ಲೋಡ್ ಮಾಡಿದ್ದೀನಿ. ಓಕೆ, ಫಸ್ಟ್ 20 ಎಲಿಮೆಂಟ್ಸ್ ನ. ಸಿ ಇಲ್ಲಿ hydrogen is the first element, so atomic number 1. Helium is the second element, so atomic number is 2. Lithium atomic number 3, then 4, 5. So ಇದು increasing order of atomic number ಇದೆ. ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಏನಿದೆ increasing order of atomic number ಇದೆ. ಮಿಡಲ್ ಅಲ್ಲಿ ಬರುವಂತ ನೀವು ಏನಿದೆ ಗ್ರೂಪ್ ನಂಬರ್ 3 to ಗ್ರೂಪ್ ನಂಬರ್ 12 ಯಾವುದೇ ಎಲಿಮೆಂಟ್ಸ್ ಕೂಡ ನಿಮ್ಮ ಎಕ್ಸಾಮ್ಗೆ ಬೇಡ. ಫಸ್ಟ್ 20 ಎಲಿಮೆಂಟ್ಸ್ ಮಾತ್ರ ಕಲ್ತ್ಕೊಳ್ಳಿ. ಫಸ್ಟ್ 20 ಎಲಿಮೆಂಟ್ಸ್ ಕಲ್ತ್ಕೊಂಡ್ರೆ ಸಾಕು, ನಿಮ್ಗೆ ಫುಲ್ ಮಾರ್ಕ್ಸ್ ಬರುತ್ತೆ ಈ ಲೆಸನ್ ಅಲ್ಲಿ. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಫಸ್ಟ್ 20 ಎಲಿಮೆಂಟ್ಸ್ ಬೇಸಿಸ್ ಆಗೇನೆ ಕ್ವಶನ್ಸ್ ನ ಕೇಳೋದು. ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಯು ವಾಂಟ್ ಟು ನೋ. ಎಸ್, ಅಟಾಮಿಕ್ ನಂಬರ್ ಕಲ್ತ್ಕೊಳ್ಬೇಕಾ? ಎಸ್, ಅಟಾಮಿಕ್ ನಂಬರ್ ಗೊತ್ತಿರ್ಬೇಕು. ಅಟಾಮಿಕ್ ಮಾಸ್ ಬೇಡ, ಅಟಾಮಿಕ್ ನಂಬರ್ ಗೊತ್ತಿರ್ಬೇಕು. ಅಟಾಮಿಕ್ ಮಾಸ್ ಕೇಳೋದಾದ್ರೆ ಓನ್ಲಿ ಫ್ಯೂ ಅಟಾಮಿಕ್ ಮಾಸ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಹೈಡ್ರೋಜನ್ ಅಟಾಮಿಕ್ ಮಾಸ್ ಅಟಾಮಿಕ್ ನಂಬರ್ 1 ಆದ್ರೆ ಮಾಸ್ 2 ಆಗಿರುತ್ತೆ. ಓಕೆ, ಸೊ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಲರ್ನ್ ಓನ್ಲಿ ದ ಅಟಾಮಿಕ್ ನಂಬರ್ ಚಿಲ್ಡ್ರನ್. ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಲರ್ನ್ ಓನ್ಲಿ ದ ಅಟಾಮಿಕ್ ನಂಬರ್. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ? ಸೊ ಫಸ್ಟ್ 20 ಎಲಿಮೆಂಟ್ಸ್ ನ ಕಲ್ತ್ಕೊಳ್ಬೇಕು. ಫಸ್ಟ್ 20 ಎಲಿಮೆಂಟ್ಸ್ ಗೊತ್ತಿದ್ರೆ ನೀವು ಫರ್ದರ್ ಏನ್ ಬೇಕಾದ್ರೂ ಆನ್ಸರ್ ಮಾಡ್ಬೋದು. ಸೊ ಯಾವ ಎಲಿಮೆಂಟ್ ಯಾವ ಪೀರಿಯಡ್ ಇದೆ, ಯಾವ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಇದೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡಿ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಾನು ನಿಮ್ಗೆ ಹೇಳಿದೆ ಇದು ಫಸ್ಟ್ ಗ್ರೂಪ್ ಅಂತ ಹೇಳಿದೆ, ಇದು ಸೆಕೆಂಡ್ ಗ್ರೂಪ್ ಅಂತ ಹೇಳಿದೆ. ದೆನ್ ಐ ಟೋಲ್ಡ್ ಯು ದಿಸ್ ಇಸ್ ದ 13th group and this is the 14th group. Okay, let us write this is 14th group, this is the 15th group I told you, and this is the 16th group I told you, and followed by this is the 17th group, and this is the 18th group. 18th group elements are all inert gases, noble gases. Okay, then I told that we are going to learn the 4 periods. 4 periods held alva. So this is the first period, this is the first period, yes, first period, second period, third period, and fourth period. Let me ask you a question. Name the element which belongs to 15th group, third period. Name the element. Let me see who will answer first. Name the element which belongs to 15th group and third period. Look at the periodic table which I have written and answer. Name the element which belongs to 15th group and third period. Yes, correct answer first is given by Artism, followed by Tulsi, followed by Shashank, followed by Veda, Navya, So Aishwarya, many have given. Geeta Shri, Ashwini, okay, Venkatesh, many have given right answer. Very good. See, how do you identify? Exam alli keltare. So name the element or identify the element which belongs to 15th group and third period anta helde. 15th group, third period anta heldaga, what do you identify? See, check out 15th group. Nodi 15th group na check ಮಾಡ್ಕೊಳ್ಳಿ. 15th group ಅಂದಾಗ 15th group ಗೆ ಬರಬೇಕು. ಓಕೆನಾ? 15th group ನೋಡ್ಕೊಳ್ಳಿ. ಥರ್ಡ್ ಪೀರಿಯಡ್ ಅಂತ ಅಂದಾಗ ಏನ್ ಬೇಕು? ಥರ್ಡ್ ಪೀರಿಯಡ್ ಹತ್ರ ಬನ್ನಿ. ಓಕೆನಾ? 15th group ಅಲ್ಲಿ ಥರ್ಡ್ ಪೀರಿಯಡ್ ಅಲ್ಲಿ ಇರುವಂತ ಎಲಿಮೆಂಟ್ ಯಾವುದು? ಫಾಸ್ಫರಸ್. Phosphorus is there. So this is how you will identify the elements in the examination. Let me ask you another question. Okay. Name the element which is found in the second period and 18th group. 18th group and second period. Let me see who will answer. Second period and 18th group. Which is the, let me see who will answer. Second period and 18th group. Very good. The correct answer first is given by Aarti, followed by Autism, followed by Aesthetic Girl, Navya, Salma, Tulsi, Leona, Shashank. Many are giving right answer. Yes. How to identify, dear students? I told you, name the element which belongs to 18th group I told. Okay. So 18th group means look at 18th group. I told you second period. So the second period means move on to the second period. So second period only 18th group ಅಲ್ಲಿ ಇರುವಂತ ಎಲಿಮೆಂಟ್ ಯಾವುದು? ಇಲ್ಲಿ ನಿಯಾನ್. ಓಕೆ, ಇದೇ ರೀತಿ ನೀವು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಐಡೆಂಟಿಫೈ ಮಾಡ್ತೀರಾ. ಸೊ ಈ ರೀತಿ ಐಡೆಂಟಿಫೈ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಈ ಪೀರಿಯಾಡಿಕ್ ಟೇಬಲ್ ಗೊತ್ತಿರಬೇಕು ನಿಮ್ಗೆ. ನಾನು ಏನ್ ಇಲ್ಲಿ ಬರ್ದಿದ್ದೀನಿ ನಿಮ್ಗೆ, ಫಸ್ಟ್ 20 ಎಲಿಮೆಂಟ್ಸ್ ನ ಒಂದು ಪೀರಿಯಾಡಿಕ್ ಟೇಬಲ್. ಸೊ ಈ ಎಕ್ಸಾಕ್ಟ್ ಟೇಬಲ್ ನ ನೀವು ಬರೆಯೋದನ್ನ ಕಲ್ತ್ಕೊಳ್ಳಿ. ವೆರಿ ಈಸಿ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್. ಫಸ್ಟ್ 20 ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ವೆರಿ ಈಸಿ. ನಿಮ್ಗೆ ಯೂಶಲಿ ಕೇಳ್ತಾರೆ. ಸೊ ಏನ್ ಕೇಳ್ತಾರೆ ಅಂದ್ರೆ, an element X, listen to this question. Okay, element X is present in the second period in the first group. Element X is present in second period. Second, okay, let me write second period and also the first group. It is present in the first group. Name the element X anta keltare. Name the element X. Tell me which is the element X. Which is the element X? An element X is present in the second period and first group. So which is that element? Very good. First answer is given by the Shrikant, followed by Salma, Leona, Aarti, Ligita, Autism, Venkatesh. Many have given right answer. See, I told you, you don't know which is the element. They're asking name the element X which is belong to second period. So which is the second period? This is the second period. Okay. So I told you the first group. So first group aliruvanta second period naliruvanta element yavadu? Lithium. So the element X is lithium. So you will write like this in the examination. So ನಿಮಗೆ ಈ ಪೀರಿಯಡ್ ಗೊತ್ತಿದ್ರೆ, ಈ ಪೀರಿಯಾಡಿಕ್ ಟೇಬಲ್ ನಾನು ಏನು ಮೆನ್ಷನ್ ಮಾಡಿದೀನಿ ಈ ರೀತಿ ನಿಮ್ಗೆ ಬರೆಯೋದು ಗೊತ್ತಿದ್ರೆ, ಡೆಫಿನೆಟ್ಲಿ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಫುಲ್ ಮಾರ್ಕ್ಸ್. ಈ ರೀತಿ ಕ್ವಶನ್ಸ್ ಕೇಳಿದಾಗ ಫುಲ್ ಮಾರ್ಕ್ಸ್ ಸಿಗುತ್ತೆ ನಿಮ್ಗೆ. ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಐ ಥಿಂಕ್ ಯು ಡೋಂಟ್ ಹ್ಯಾವ್ ಎನಿ ಡೌಟ್ ಇನ್ ದಿಸ್. ಲೆಟ್ ಮಿ ಮೂವ್ ಫಾರ್ ಟ್ರೆಂಡ್ಸ್ ಹೇಳ್ಕೊಡ್ತೀನಿ ನಾನು ನಿಮ್ಗೆ. ಆರ್ ಯು ಕ್ಲಿಯರ್ ವಿತ್ ದಿಸ್ ಟಾಪಿಕ್? ಶಾಲ್ ಐ ಮೂವ್ ಫಾರ್ವರ್ಡ್? ಸೊ ಇಫ್ ದೇ ಆಸ್ಕ್ ಇನ್ ಎಕ್ಸಾಮಿನೇಷನ್, ನೌ ಯು ಆರ್ ರೆಡಿ ಟು ರೈಟ್ ನೋ. ಸೊ ಶಾಲ್ ಐ ಮೂವ್ ಫಾರ್ವರ್ಡ್? Yes. So if you don't have any doubt, I will move forward. Yes, very good. Fine. So now I'm going to next concept, that is children, trends in the modern periodic table. I'm going to teach you trends in modern periodic table. When I talk about trends, let me first talk about valency. So in examination, they will ask you what happened to valency across the period and down the group. See, firstly, listen. When I tell about across the period, you have to go from left to right. Because period starts going from left to right. These are periods. See, first period, second period, third period, fourth period. When I talk about period, we have to go always from left to right. When I talk about top to bottom ಅಂದಾಗ ಏನ ಮಾಡಬೇಕು? You have to look at the group. Top to bottom means group wise. Left to right means it is period. Okay, ಅದನ್ನ ನಾವೇನ್ ಹೇಳ್ತೀವಿ? Across the period ಅಂತ ಹೇಳ್ತೀವಿ. Across the period ಅಂದ್ರೆ left to right. Down the group ಅಂದ್ರೆ top to bottom. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ? ಸೊ ದಿಸ್ ವರ್ಡ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಅಕ್ರಾಸ್ ದ ಪೀರಿಯಡ್ ಅಂದ್ರೆ ಲೆಫ್ಟ್ ಟು ರೈಟ್, ಟಾಪ್ ಟು ಬಾಟಮ್ ನ ನಾವು ಡೌನ್ ದ ಗ್ರೂಪ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ, ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಟು ವೇಲೆನ್ಸಿ ಅಕ್ರಾಸ್ ದ ಪೀರಿಯಡ್ ಅಂಡ್ ಆಲ್ಸೋ ಡೌನ್ ದ ಗ್ರೂಪ್. ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಟು ವೇಲೆನ್ಸಿ ಅಕ್ರಾಸ್ ದ ಪೀರಿಯಡ್ ಅಂಡ್ ಡೌನ್ ದ ಗ್ರೂಪ್? ಲೆಟ್ ಮಿ ಟೇಕ್ ಒನ್ ಟೇಬಲ್ ಅಂಡ್ ಎಕ್ಸ್ಪ್ಲೇನ್. ಒನ್ ಟೇಬಲ್ ತಗೊಂಡು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ ನೋಡಿ. ಸೊ ಹಿಯರ್ ಐ ಹ್ಯಾವ್ ಟೇಕನ್ ದ ಥರ್ಡ್ ಪೀರಿಯಡ್. ಸೊ ವಿ ಆರ್ ಟಾಕಿಂಗ್ ಫಸ್ಟ್ ಅಬೌಟ್ ಅಕ್ರಾಸ್ ದ ಪೀರಿಯಡ್. ಅಕ್ರಾಸ್ ದ ಪೀರಿಯಡ್ ನಾವು ಮಾತಾಡ್ತಾ ಇದ್ದೀವಿ. So what are we talking about? We are talking about the valency. You know what happens to valency? See, for example, see across the period, when I talk about the third period we have taken. So in the third period, okay, let me take out this line and write the atomic number of this. So to make you identify very easily. Okay. So we are talking across the period, now. So the atomic number of sodium is 11, atomic number of magnesium is 12, followed by atomic number of aluminum is 13, and atomic number of silicon is 14, atomic number of phosphorus is 15, and atomic number of sulfur is 16, atomic number of chlorine is 17. Let me give you few examples and tell you to understand this very clearly, dear students. See, when we look at these are the atomic numbers, 11th element, 12th element, 13th element, 14th element, they are all always in the increasing order of their atomic number. So when we talk about what happens to valency across the period, see, valency, I told you about valency send out. Valency is nothing but a combining capacity. Okay. So when we look at across the period, see, sodium is 11th element. So on the first shell of the sodium, 2 element. On the second shell of the sodium, there are 8 electrons. And the third shell of the sodium, there is 1 electron. Okay. I repeat once again. On the first shell of sodium, there are 2 electrons. On the second shell of sodium, there are 8 electrons. On the third shell of sodium, it is 1 electron. So now for the sodium, if it has to become stable, it needs 7 more electrons because stability ಅಂತಂದ್ರೆ ಏನು obtain the octave configuration. See, octave configuration and obtain ಮಾಡ್ಕೊಳ್ಬೇಕಂದ್ರೆ sodium ಗೆ 7 more ಬೇಕು. So what do sodium do? Sodium, instead of gaining 7, what will it do? It will lose 1. So here the valency of sodium is 1. Okay. Similarly, when we look at the magnesium, so on the first shell of magnesium, 2 electrons. On the second shell of the magnesium, there are 8 electrons. On the third shell of magnesium, there are 2 electrons. 12th element, 2 plus 8 plus 2, 12. So now for the magnesium to obtain the stability, it needs 6. 8 agbekanದ್ರೆ 6 ಬೇಕು. So what do magnesium do? Instead of taking 6 electrons, it will lose easily 2 electrons. So 2 is the valency. It can easily lose. So now aluminium allo ಅಷ್ಟೇ. When it comes to aluminium, let me now take out this and write this as aluminium. So aluminium na bardaga, aluminium, okay. So on the first shell of aluminium, there are 2 electrons. On the second shell of aluminium, 8 electrons. On the third shell of aluminium, there are 3 electrons. So aluminium need now 5 more to become 8 to obtain the stability. What do aluminium do? Instead of taking 5, it will lose 3. So the valency is 3. When it comes to silicon, silicon is the 14th element. So silicon, on the first shell of silicon, so 2 electrons are there, and on the second shell 8 electrons are there. On the third shell there are 4 electrons. What do silicon do? Silicon neither lose nor gain. It will share the electrons. So the valency of silicon is 4. When it comes to phosphorus, so phosphorus is the 15th element. Look at the phosphorus. So when we look at the phosphorus, it is the 15th element. Okay. So on the first shell of phosphorus, there are 2 electrons. On the second shell, it is 8. On the third shell, there are 5 valence electrons. So now for the phosphorus to obtain the stability, it needs only 3, dear students. There are 5 already. So instead of losing 5, phosphorus will take 3. So what is the valency here? So the valency will be 3. What is the valence electron? Valence electron will be the 5. Understand? Valency is nothing but the combining capacity. You can see valency is nothing but the combining capacity. So now what happened? Now first it has increased. Again now what happened? It is decreasing. Again now it is decreasing. Okay. So you have to understand what is happening to valency here. Firstly it is increasing. It has lost 1. It has lost 2. It has lost 3. Then it has shared. Again now what happened? Instead of increasing, it has decreased. Now it is decreasing. Phosphorus, what happened? Instead of losing 5, it is gaining 3. Valency is now 3. It is decreased. Again, when it comes to sulfur, instead of losing 6, it has gained 2. Chlorine, instead of losing 7, it has gained 1. So argon, it is already satisfied with the 8 valence electron. Understand? So when we look at the valency, when we move from left to right, or what happened? Firstly, it will increases. Then what happened? It will decreases. Firstly, it will increases. Then it will decreases. Understand? I think you are clear with this topic. Artha aitidalva? You are clear with this topic, right? You all are clear with this topic, right? What happens to valency? When we move from left to right. Okay, when we move from left to right, first it increases. Then it decreases. You are clear with this topic, right? Yes, if you are clear with this, okay, let me move for next, children. So you also should know what happens to valency down the group. See, when we look at the group, okay, So the valency of the elements does not alter. It does not alter. It remains same, dear students. For example, let me give you one example. Let me take first group. So in first group, the first element is hydrogen. So in the first group, the third element is lithium. And then comes the 11th element, that is the sodium. And then comes the 19th element, the potassium. See, if we look at the first group element, so hydrogen is the atomic number having only one valence electron. Lithium will having, it is a third element. Okay. So on the first shell 2 and also second shell 1. When it comes to sodium, on the first shell it is 2, on the second shell it is 8, and the third shell it is 1, and on the third shell it is 1. Okay. When it comes to potassium, on the first shell it is 2, on the second shell it is 8, and also on the third shell it is 8, and on the fourth shell it is 1, dear students. Okay. Look at the last. What are you looking? So the number of electrons remain same in the outermost orbit. So the valency does not alter here. The valency remains same. Understand? The valency remains same. So very importantly, you want to understand about these children. Okay. So you are clear with this thing, I think. Okay. So let me explain you now what happened to valence electrons when we move from top to bottom and across the period. So what happens to valency? First tell me. Valency, when we go from left to right. When we go from left to right, valency first increases, then decreases. What about to valency down the group? Down the group means we have to come from top to bottom. So when we come to top to bottom, the valency does not alter. It remains the same. The valency does not alter. It remains same. Okay. So now let us talk about what happens to valence electron across the group and also down the period. What happens to valence electron? So let me tell you what happens to valence electron. See, here only, this group only, let me give you as an example. See, when we look at the valence electron, okay, take out this. So now don't look at this particular column. Don't look at, because now we are talking about the valence electron, not the valency. This one I have given for valency. When we look at valence electron, what is meant by valence electron? Valence electrons are the number of electrons found on the outermost orbit of that particular atom. Okay. For example, sodium. So sodium's valence electron. So first sodium's electronic configuration is 2, 8, 1. Okay. So then when it comes to magnesium, magnesium's electronic configuration is 2, 8, 2. 2, 8, 2. When it comes to aluminium, it is 2, 8, 3. Okay, 2, 8, 3. It is 2, 8, 3. When it comes to silicon, it is 2, 8, 4. 2, 8, 4 is the valence electron for the, the silicon. When it comes to phosphorus, it is 2, 8, 5. Look at here, 2, 8, 5 is the electronic configuration. Similarly, when it comes to, sulfur, it is 2, 8, 6. What are you observing, dear students? When I talk about the valence electron, see, valence electron is the number of electrons found in the outermost orbit. Look at the first orbit of first element, 1 electron. Second element, 2 electrons. Third element, 3 electrons. Fourth element, 4 electrons. Fifth element, 5 electrons. Sixth element, 6 electrons. So when we move across the period, when we are moving across the period, so valence electron increases. Valence electron increases. Across the period, valence electron increases. Down the group, see, down the group, valence electron increase ಆಗ್ತಿದ್ಯಾ? No. Sodium ಆಗಿರ್ಬೋದು, lithium ಆಗಿರ್ಬೋದು, potassium, soda, that is potassium ಆಗಿರ್ಬೋದು. So ಎಲ್ಲದಕ್ಕೂ ಏನಾಗಿದೆ? Number of valence electron remains same. Down the group, number of valence electron remains same. It does not alter. But when we move from left to right, what happens? The valence electron increases. Okay, valence electron increases from left to right, top to bottom. It does not alter. It remains the same. So this is all about valency and valence electron. It is very important, dear student. It is very important to know what happens to valency across the period and also down the group. Do you have any doubt in this? Do you have any doubt? If you don't have any doubt, I will move forward. Thank you so much for giving the quick reply, children. I think you said you don't have any doubt. So you have to very much clear that what happens to valency across the period, valence electron across the period. Valency first increases, then decreases. But valence electron, it increases. Understand? Yes. So now let us understand the next trend, that is the atomic size. Students, here you can also expect that 1 mark question they can ask, define atomic radius anta kelbodu. So how will you define the atomic radius? It's a very important topic because in one of the examination they have asked it. What is meant by atomic size? See, it is given in your textbook. I think you are not seen. Atomic size is nothing but distance between the center of the nucleus and also the outermost shell of an isolated atom. That means, for example, if I write the atom, okay, so this will be the nucleus. This will be the nucleus, right? What is meant by atomic radius? Radius is only half. So it is the atomic radius is the distance between the center of the nucleus and also the outermost shell. Okay, outermost shell. So this distance is there. No, this is called as atomic radius. See, I have mentioned here. Atomic size refers to the radius of an atom. It may be visualized as the distance between the center of the nucleus and also the outermost shell. This is what is called as atomic size. It can be asked for 1 mark question in the examination. Okay, yes. So now let us understand what happens to atomic size across the period and down the group. Tumba janake idu doubt ide. Okay, atomic radius ಏನಾಗುತ್ತೆ, atomic size ಏನಾಗುತ್ತೆ, exam ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ. So by giving 2 elements, they will ask which element is having the more atomic size, which is having the least atomic size ಅಂತ ಕೇಳ್ತಾರೆ. So illi what happens to atomic size ನೋಡಿ. See, let me take the one of the group. Let me take one of the group. Okay, here only the group is there. So this is the third group element. That is the third period element. So third period element. So third period element, firstly sodium, followed by magnesium, aluminum, silicon, phosphorus, sulfur and chlorine. Okay, see, atomic numbers, the atomic number of sodium is 11, atomic number of magnesium is 12, atomic number of aluminum is 13, followed by silicon is 14, followed by phosphorus is 15, followed by sulfur is 16 and also chlorine is 17. So look at these elements. Look at these elements. See, when I talk about atomic size, see, sodium, let me write the sodium's atomic structure. Sodium, okay. On the first shell of sodium, there are 2 electrons. On the second shell of the sodium, there is 8 electrons. Okay, there are 8 electrons. And on the third shell of the sodium, there is 1 electron, dear students. 1 electron, dear students. So why I'm explaining this, I'll tell you. See, let me now tell about magnesium. So when I write magnesium, okay, on the first shell of magnesium, there are 2 electrons. On the second shell of magnesium, okay, there is 8 electrons, okay. And on the third shell of magnesium, there are 2 electrons. Dear students, when I talk about the atomic size, what happens to atomic size when we move from left to right? I am now talking about left to right. See, in the left to right, first of all, observe. See, when I talk about third period, only 3 shells will be there. When I talk about first period, there will be only 1 shell. When I talk about second period, there are only 2 shells. Number of shells does not vary across the period. See, for example, sodium and magnesium both are having 3 shells. Aluminum, when I write, aluminum is also having 3 shells. But my question is, what happened to atomic size when we move from left to right? See, when we move from left to right, atomic size will decrease. Why, ma'am? Because there is 1 electron here, there are 2 electrons here. How it is possible to decrease? Number of electrons are more, right? How it is possible to decrease? Dear students, when we move from left to right, as the number of electrons are increasing, the attraction between the nucleus and the outermost orbit's electron increases. For example, when we take sodium, there is only 1 valence electron outside. When magnesium, there are 2 valence electrons. When it comes to silicon, there are 4 valence electrons. As the number of valence electron increases, nuclear force increases. Understand? Nuclear force in the sense, the attraction between the nucleus and also the outermost orbits increases. That means this shell will be pulled inside. Okay. As the number of electron increases, this shell will be pulled inside. So it will get shrinked. Size of the atom decreases as the number of electron increases on the outermost orbit. So that is the reason, when we move from left to right, what happened? The atomic size decreases. In examination, they can ask element with the atomic number 11 and element with the atomic number 15. So two elements are given. Among these two elements, which element is having the least atomic size and which element is having the most atomic size? You have to justify. Justify anta keltare. What do you write for this? Yen baritira? You will write, see, the atomic number with the 11 element is the sodium. He is having the most atomic size. It is having the more atomic size compared to the element which is having the atomic number 50. That is the silicon is having the least atomic size. Because number of electrons are more, valence electrons are more on the silicon. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ? ಯಾಕೆ ಅಂದ್ರೆ ಸಿ ನಂಬರ್ ಈಗ ಲೆಫ್ಟ್ ಇಂದ ರೈಟ್ ಹೋಗ್ತಾ ಇದ್ದಂಗೆ ಏನಾಗುತ್ತೆ, ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ನಾನು ನಿಮ್ಗೆ ಇಲ್ಲಿ ತೋರಿಸಿದೆ. ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಾಗ್ತಾ ಇದೆ, 1 ಇದೆ, 2 ಇದೆ, 3 ಇದೆ, 4 ಇದೆ, 5 ಇದೆ, 6 ಇದೆ. When we go from left to right ಏನಾಗ್ತಾ ಇದೆ, valence electrons are increasing. As the valence electrons are increasing, what happened? The attraction between the nucleus and the outermost orbit is increasing. So ಏನಾಗುತ್ತೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಈಗ ಮೆಗ್ನೀಷಿಯಂಗೂ ಸಲ್ಫರ್ಗೂ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ, ಸಲ್ಫರ್ ನಲ್ಲಿ ಏನಾಗಿದೆ, ಫಸ್ಟ್ ಆರ್ಬಿಟ್ ಅಲ್ಲಿ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ, ಸೆಕೆಂಡ್ ಆರ್ಬಿಟ್ ಅಲ್ಲಿ ಏನಾಗಿದೆ 8 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ. ಓಕೆ, ಥರ್ಡ್ ಆರ್ಬಿಟ್ ಅಲ್ಲಿ ಸಲ್ಫರ್ 16th ಎಲಿಮೆಂಟ್ ಅಲ್ವಾ, ಸೊ ಥರ್ಡ್ ಆರ್ಬಿಟ್ ಅಲ್ಲಿ 6 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ. So compared to magnesium and sulfur, number of valence electrons for the sulfur is more. So the attraction is more for the sulfur compared to magnesium. So atomic size nodadadre magnesium is having bigger atomic size compared to sulfur, because atomic ಏನಾಗುತ್ತೆ size decrease ಆಗುತ್ತೆ. As we go from left to right, atomic size decrease ಆಗುತ್ತೆ. ಯಾಕಂದ್ರೆ electrons ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದ್ದಂಗೆ ಏನಾಗುತ್ತೆ, attraction between the nucleus and outermost orbits ಏನೇನು attraction increases. As attraction increases ಏನಾಗುತ್ತೆ, ಹೊರಗಡೆ ಇರುವಂತ ಶೆಲ್ ಏನಾಗುತ್ತೆ, ನ್ಯೂಕ್ಲಿಯಸ್ ಒಳಗಡೆಗೆ pull ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. So nuclear force increases. As nuclear force increases, the shell shrinks. Okay, this is about the left to right. So what happened to atomic size down the group? Down the group ಏನಾಗುತ್ತೆ ನೋಡಿ, ಇಲ್ಲೊಂದಷ್ಟು ಎಲಿಮೆಂಟ್ ಬರ್ದಿದ್ದೀನಿ. ಹೈಡ್ರೋಜನ್. ಹೈಡ್ರೋಜನ್ ನ ಔಟರ್ ಮೋಸ್ಟ್ ಆರ್ಬಿಟ್ ನಲ್ಲಿ ಆಲ್ರೆಡಿ ನಾನು ನಿಮಗೆ ಹೇಳಿದೆ. Okay, let me write and show you. Let me write and show you. Okay, so when I write, see, hydrogen, okay, so outermost orbit, see, hydrogen atomic number 1. So when I write down the group, third element will be lithium in second period 2,1. Okay, so when I come to hydrogen, lithium, then third element in the first group is sodium, that is 2,8,1. Okay, so when it move for next element in the first group, it is not magnesium, it is potassium. Okay, sorry, it is potassium. Okay, so when I write potassium, it is 2,8,8,1. What are you observing? The number of valence electrons are remaining same in the group. Okay, down the group, the number of valence electrons remain same. But what happened in the first period, the first hydrogen is having only one shell. So lithium, what happened? It has 2 shells. See, on the first shell 2 electrons, on the second shell 1 electron. Okay, so when it comes to sodium, on the first shell 2 electrons, on the second shell 8 electrons, on the third shell what happened, 1 electron, like that. So sodium, when it comes to potassium, what happened, first shell 2 electrons, second shell 8 electron, third shell 8 electron, fourth shell 1 electron. When you look at here, the number of shells are increasing. As the number of shells increasing down the group, the atomic size increases. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? So left to right ಏನಾಯ್ತು, decrease ಆಯ್ತು, because of the nuclear force increases. Down the group ಏನಾಯ್ತು, as the shells are increasing, the atomic size increases down the group. Down the group ಏನಾಗುತ್ತೆ, atomic size increase ಆಗುತ್ತೆ, left to right ಏನಾಗುತ್ತೆ, decrease ಆಗುತ್ತೆ. I think you are clear with this concept, dear students. Okay, if you are clear with this concept, I will move forward. If you are clear with this concept, I will move forward. Yes, so we are left with only few topics and very important topics. Yes, so the next thing which I would like to explain you is the metallic character. I'm going to explain you about the metallic character. Yes, so what is meant by metallic character? Metallic character is also having another name, that is the electropositivity. Metallic character is nothing but the electropositivity. See, next trend is metallic character. So what happened to metallic character across the period? They can ask. What happened to metallic character down the group? They can ask. Okay, they can or not, they will ask. Okay, what is meant by metallic character? Metallic character is nothing but the electropositivity. Electropositivity andre enu? Electropositivity is nothing but the tendency of an atom to lose the electron. See, it's very simple, dear student. Nenpitkolli. Metallic character andre tendency to lose electron. Metallic character andre enu? Tendency to lose electron. Electropositivity andre enu? Electropositivity is also nothing but the tendency to lose electron. Okay, both are same. Okay, so what happens to the metallic character across the period anta keltare. Across the period metallic character ಏನಾಗುತ್ತೆ? See, tendency to lose anta ಹೇಳ್ದೆ. See, for example, when I take again the same period, third period ತಗೊಳ್ತೀನಿ. ಯಾಕೆಂದ್ರೆ we have more number of elements here. See, sodium with the atomic number 11 ಅಲ್ವಾ? Electronic configuration ಏನಾಗುತ್ತೆ? ನಾನು already ಬರ್ದಿದ್ದೀನಿ many times. 2, 8, 1. So magnesium ಏನಾಗುತ್ತೆ? Atomic number 12, 2, 8, 2. 2, 8, 2. ಅಲ್ವಾ? Sodium, magnesium ಆದ್ಮೇಲೆ aluminum with the electronic configuration 2, 8, 3 ಇದೆ. ಓಕೆನಾ? So then ಏನಾಗುತ್ತೆ? Sodium, magnesium, aluminum ಆದ್ಮೇಲೆ silicon with the electronic configuration 2, 8, 4. So sodium, magnesium, aluminum, silicon, sodium, magnesium, aluminum, silicon, phosphorus. So 2, 8, 5 ಆಯ್ತು. ಓಕೆ, ಇನ್ನೊಂದು ಬರ್ದ್ಬಿಡ್ತೀನಿ. 2, 8, 5. ಸಿಲಿಕಾನ್ ಆದ್ಮೇಲೆ ಫಾಸ್ಫರಸ್ 2, 8, 6. ಬಿಕಾಸ್ ನಿಮ್ಗೆ ಅರ್ಥ ಮಾಡಿಸ್ಬೇಕಂದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ನೋ ದಿಸ್. ಸೊ ನಾನು ಏನ್ ಹೇಳ್ತಾ ಇದ್ದೀನಿ? ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಏನಾಗುತ್ತೆ? ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಅಂದ್ರೆ ಏನು? ಟೆಂಡೆನ್ಸಿ ಟು ಲೂಸ್ ಎಲೆಕ್ಟ್ರಾನ್. ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಟು ದ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಅಕ್ರಾಸ್ ದ ಪೀರಿಯಡ್? ಅಕ್ರಾಸ್ ದ ಪೀರಿಯಡ್ ಏನಾಗುತ್ತೆ ಅಂತ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ. ಸೊ ನೋಡಿ, ಅಕ್ರಾಸ್ ದ ಪೀರಿಯಡ್ ಏನಾಗುತ್ತೆ? ಫಸ್ಟ್ ಸೋಡಿಯಂ ನ ನೋಡಿದಾಗ ಸೋಡಿಯಂ ಅಲ್ಲಿ ಒಂದೇ ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ ಔಟರ್ ಮೋಸ್ಟ್ ಆರ್ಬಿಟಲ್. ಇದು ಆಕ್ಟೇಟ್ ಕಾನ್ಫಿಗರೇಷನ್ ಅನ್ನು ಆಬ್ಟೈನ್ ಮಾಡಬೇಕಂದ್ರೆ ಇನ್ನು 7 ಬೇಕು. ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಟೇಕಿಂಗ್ 7, ಇಟ್ ವಿಲ್ ಲೂಸ್ 1. ಇಟ್ ವಿಲ್ ಲೂಸ್ 1 ಈಸಿಲಿ. ನೆಕ್ಸ್ಟ್ ಸಿಮಿಲರ್ಲಿ ಇಲ್ಲಿ ಸೋಡಿಯಂ ಆದ್ಮೇಲೆ ಮೆಗ್ನೀಷಿಯಂಗೆ ಬಂದಾಗ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ ಔಟರ್ ಮೋಸ್ಟ್ ಆರ್ಬಿಟಲ್. ಮೆಗ್ನೀಷಿಯಂ ಈಗ ಸ್ಟೇಬಲ್ ಆಗ್ಬೇಕಂದ್ರೆ 6 ಬೇಕು. ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಟೇಕಿಂಗ್ 6, ಇಟ್ ವಿಲ್ ಲೂಸ್ 2. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಮೂವಿಂಗ್ ಟು ಅಲ್ಯೂಮಿನಿಯಂ, 3 ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ದೇರ್. ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಟೇಕಿಂಗ್ 5 ಬೇಕು ಇದು ಸ್ಟೇಬಲ್ ಆಗಕ್ಕೆ. Instead of taking 5, it will lose 3. Next ಏನಾಗ್ತಾ ಇದೆ? 4 ಇದೆ. ಇದೇನ್ ಮಾಡುತ್ತೆ? ಶೇರ್ ಮಾಡುತ್ತೆ. ಮೂವಿಂಗ್ ಟು ನೆಕ್ಸ್ಟ್ ಫಾಸ್ಫರಸ್ ಏನಾಗುತ್ತೆ? 5 ಇದೆ. ಸೊ 5 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಈಗ ಏನಾಯ್ತು? ಲೂಸ್ ಮಾಡ್ಕೊಳ್ಬಾರ್ದು ಬದಲು ಇದೇನಾಗ್ತದೆ? ಗೈನ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದೆ. ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಲೂಸಿಂಗ್ 5 ಏನಾಗ್ತಾ ಇದೆ? ಇಟ್ ವಿಲ್ ಗೈನ್ 3. ಸೊ ಹಿಯರ್ ನಾವು ವಾಟ್ ಹ್ಯಾಪನ್? ಲೂಸಿಂಗ್ ಸ್ಟಾಪ್ಡ್, ಗೈನಿಂಗ್ ಇನ್ಕ್ರೀಸೆಡ್. ಮೂವಿಂಗ್ ಟು ಸಲ್ಫರ್ ಅಲ್ಲೂ ಕೂಡ 6 ಇದೆ. ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಲೂಸಿಂಗ್ 6, ಇಟ್ ವಿಲ್ ಟೇಕ್ 2. Similarly, chlorine ಗೆ ಬಂದಾಗ 7 ಇರುತ್ತೆ. Instead of losing 7, it will take 1. What are you observing? As we move from left to right, tendency to lose electron is decreasing because first it has lost. See, 1 it has lost, 2 it has lost, 3 it has lost, 4 it has shared, 5 stop losing, started gaining. 6 stop losing, started gaining. So, when we move from left to right, tendency to lose electron decreases. Tendency to lose electron decreases. But when we move from top to bottom, dear students, tendency to lose electron increases. ಯಾಕೆ? ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ನಾನು ನಿಮ್ಗೆ ಹೇಳ್ದೆ ಆಲ್ರೆಡಿ. ಸೊ ಏನಾಗುತ್ತೆ? ಟಾಪ್ ಟು ಬಾಟಮ್ ಗೆ ಬಂದಾಗ, ಸೊ ಲೆಟ್ ಮಿ ಟೇಕ್ ಎನ್ ಎಕ್ಸಾಂಪಲ್. ಓಕೆ, ಲೆಟ್ ಮಿ ರೈಟ್ ಹಿಯರ್. ಸೊ ಹಿಯರ್ ಓನ್ಲಿ ಐ ವಿಲ್ ರೈಟ್. ಟಾಪ್ ಟು ಬಾಟಮ್ ಬಂದಾಗ ಹೈಡ್ರೋಜನ್ ಇದೆ, ಲಿಥಿಯಂ ಇದೆ, then we have the sodium and we also have the potassium. You can take any groups, dear students. Okay, any group ನೀವು ತಗೊಳ್ಬಹುದು. So top to bottom ಬಂದಾಗ ಏನಾಗುತ್ತೆ? outer most shell ಅಲ್ಲಿ you all have seen that only 1 valence electron is there. Okay, so it is easy for all these elements to lose the 1 valence electron. So that is the reason what happened, the metallic character increases down the group. It is easy to lose electron from top to bottom, but when we go from left to right, what happened? First it has lost, then it has stopped losing, it has started gaining. So ಏನಾಗುತ್ತೆ? metallic character will decrease down across the period, but it will increase down the group. So ಏನಾಯ್ತು? It will decrease across the period, but it will increase down the group. Very important, dear students. I think you are clear with this concept. ಅರ್ಥ ಆಗ್ತದೆ ಅಲ್ವಾ? So you are clear with this concept, right? Shall I go for non-metallic character? See, whatever the points I mentioned here, everything I have explained. So did you understand? Did you understand this concept? So if you are clearly able to understand this concept, I will move forward to explain you the next concept. So you have understood, right? What happens to metallic character across the period? Tell me. what happens to metallic character across the period? Across the period, what happens to metallic character? What happens to metallic character across the period? Very good. Atomic character, sorry, metallic character decreases. First correct answer is given by Rakshita, followed by Sudeep, Atmika. Many have given. Pavitra, Shashank, Spurti, Sujan. Many have given. Pratima, Netra. Yes. When we move from left to right, what happened? This metallic character decreases. Metallic character andre ಏನು ಅಂತ ಗೊತ್ತಬೇಕು. Metallic character is nothing but tendency to lose electron. Left in the right ಹೋದಾಗ ಏನಾಗುತ್ತೆ? Tendency to lose electron decreases. Top in the bottom ಬಂದಾಗ ಏನಾಗುತ್ತೆ? Tendency to lose electron increases. So ನಾನು ಬರ್ದಿದ್ದೀನಿ ನೋಡಿ ಇಲ್ಲಿ. Metallic character means tendency to lose electron. Metals occupy left hand side in the periodic table. ನಿಮಗೆ ಗೊತ್ತಿದೆ. ನಾವು periodic table ನ ನೋಡಿದಾಗ modern periodic table ನಲ್ಲಿ left hand side ಅಲ್ಲೆಲ್ಲ metals ಇದೆ. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? So on moving from left to right in the period ಏನಾಗುತ್ತೆ? Metallic character of an element decreases. Metallic character of an element ಏನಾಗುತ್ತೆ? Decreases ಆಗುತ್ತೆ. And ಯಾಕೆ decrease ಆಗುತ್ತೆ? Because of the effective nuclear charge increases. So ಏನಾಗುತ್ತೆ? Instead of losing, it start to gain. So metals are electropositive in nature, children. You have to know that metals are electropositive in nature as they tend to lose the electrons. So they also form the bonds. And metallic character increases down the group. I have also explained this concept. So now let us go for non-metallic character, dear students. What is meant by non-metallic character? Non-metallic character is nothing but the tendency to gain electron. Gaining electron, we will call it as non-metallic character. So the non-metallic character is also having another name, which is called as electronegativity. Non-metallic character andru onde, electronegativity andru onde. ನಿಮ್ಮ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಟು ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಅಕ್ರಾಸ್ ದ ಪೀರಿಯಡ್ ಅಂತ ಕೇಳ್ಬೋದು ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ನಾನ್ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್. ಎರಡೂ ಕೂಡ ಒಂದೇ. ಓಕೆ, ನಾನ್ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಅಂದ್ರೂ ಒಂದೇ, ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಅಂದ್ರೂ ಕೂಡ ಒಂದೇ. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ? ಸೊ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಟು ನಾನ್ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಅಕ್ರಾಸ್ ದ ಪೀರಿಯಡ್ ಅಂತ ಕೇಳ್ತಾರೆ. ಸಿ, ವೆನ್ ವಿ ಲುಕ್ ಅಟ್ ದ ಪೀರಿಯಡ್ ಅಂಡ್ ಆಲ್ಸೋ ದ ಗ್ರೂಪ್. ಸೊ ನಾವ್ ಈಗ ತಾನೇ ಪೀರಿಯಡ್ ನ ನೋಡ್ಕೊಂಡು ಬಂದ್ವಿ. ನಾನ್ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್, ವೆನ್ ವಿ ಟೇಕ್ ಒನ್ ಆಫ್ ದ ಪೀರಿಯಡ್, ಲೆಟ್ ಮಿ ಟೇಕ್ ಸೋಡಿಯಂ. ಓಕೆ, ಸೋಡಿಯಂ, ಮೆಗ್ನೀಷಿಯಂ. Okay, sodium, magnesium, aluminium, okay, and also silicon, then sodium, magnesium, aluminium, silicon, phosphorus, sulfur, then chlorine, argon. So this is the third period elements. So what happens to non-metallic character? Non-metallic character ಅಂದ್ರೆ ಏನು? Tendency to gain electron. ಈಗ ತಾನೇ ನಾನು ನಿಮ್ಗೆ ಹೇಳ್ದೆ ನೋಡಿ, ಜಸ್ಟ್ ಸ್ಕ್ರಾಲ್ ಮಾಡಿ ತೋರಿಸ್ತೀನಿ, ಬಿಕಾಸ್ ಇನ್ನೊಂದ್ಸತಿ ಬರದೆ ನಿಮ್ಗೆ ಟೈಮ್ ವೇಸ್ಟ್ ಆಗಬಹುದು. ಸೊ ನಾನ್ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಏನಾಗುತ್ತೆ? ಸಿ, ಸೋಡಿಯಂ, ಮೆಗ್ನೀಷಿಯಂ, ಅಲ್ಯೂಮಿನಿಯಂ, ಸಿಲಿಕಾನ್, ಫಾಸ್ಫರಸ್, ಸಲ್ಫರ್. ಈಗ ತಾನೇ ಕೆಳಗಡೆ ಬರೋದಲ್ಲ, ಅದೇ ಎಲಿಮೆಂಟ್ಸ್ ನ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಇದಾಗಿದೆ. ಸೊ ನಾನ್ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಅಂದ್ರೆ ಏನ್ ಹೇಳಿದೆ? ಟೆಂಡೆನ್ಸಿ ಟು ಗೈನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅಂದೆ. ಸೊ ನೋಡಿ, ಲೆಫ್ಟ್ ಇಂದ ರೈಟ್ ಗೆ ಹೋಗ್ಬೇಕಾದ್ರೆ ಫಸ್ಟ್ ಏನಾಗುತ್ತೆ? ಒಂದ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ ಔಟರ್ ಮೋಸ್ಟ್ ಆರ್ಬಿಟ್ ಅಲ್ಲಿ, ಇಟ್ ವಿಲ್ ಈಸಿಲಿ ಲೂಸ್. ಸೊ ಸೆಕೆಂಡ್ ಏನಾಗಿದೆ? 2 ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ, 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ. 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗುತ್ತೆ? ಈಸಿಯಾಗಿ ಲೂಸ್ ಆಗುತ್ತೆ. 3 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ, ಈಸಿಯಾಗಿ ಲೂಸ್ ಆಗುತ್ತೆ. 4 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಶೇರ್ ಆಗುತ್ತೆ. 5 electrons ಇದೆ. 5 electrons ಏನಾಗ್ತಾ ಇದೆ? ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಲೂಸಿಂಗ್ ದ 5 electrons, ಇಟ್ ಸ್ಟಾರ್ಟೆಡ್ ಟು ಏನಾಗುತ್ತೆ? ಟೆಂಡೆನ್ಸಿ ಟು, ನಾನ್ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಅಂತಂದ್ರೆ ಏನಿದೆ? ಟೆಂಡೆನ್ಸಿ ಟು ಗೈನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅಂತ ಹೇಳಿದೆ ಅಲ್ವಾ? ಸೊ ಇಲ್ಲಿ ಏನಾಯ್ತು? 5 ಇದೆ, ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಲೂಸಿಂಗ್ 5 ಏನಾಯ್ತು? ಇಟ್ ಸ್ಟಾರ್ಟ್ ಟು ಗೈನ್. ಇಟ್ ವಿಲ್ ನಾಟ್ ಲೂಸ್ 5. ಸೊ ನೆಕ್ಸ್ಟ್, ಮೂವಿಂಗ್ ಟು ನೆಕ್ಸ್ಟ್ ಏನಾಗುತ್ತೆ? 16th ಎಲಿಮೆಂಟ್. 16th ಎಲಿಮೆಂಟ್ ಈಸ್ ದ ಸಲ್ಫರ್. ಸೊ ಸಲ್ಫರ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? 6 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ, ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಓಕೆ, ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಲೂಸಿಂಗ್ 6 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನ್ ಮಾಡುತ್ತೆ? ಇದು ಗೈನ್ ಮಾಡುತ್ತೆ. ಸೊ ಏನಾಯ್ತು? ಲೂಸಿಂಗ್ ಸ್ಟಾಪ್ ಆಯ್ತು, ಗೈನಿಂಗ್ ಇನ್ಕ್ರೀಸ್ ಆಯ್ತು. ವೆನ್ ವಿ ಲುಕ್ ಅಟ್ ದ ಕ್ಲೋರಿನ್ ವಿತ್ ದ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ 2,8,7 ಏನಾಗುತ್ತೆ? ಕ್ಲೋರಿನ್ ಗೆ ಓನ್ಲಿ 1 ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಬೇಕು 8 ಆಗೋದಕ್ಕೆ. ಸೊ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಲೂಸಿಂಗ್ 7, ಇಟ್ ಸ್ಟಾರ್ಟ್ ಟು ಗೈನ್. ಸೊ ಲೆಫ್ಟ್ ಇಂದ ರೈಟ್ ಗೆ ಹೋಗ್ಬೇಕಾದ್ರೆ ಏನಾಗ್ತಾ ಇದೆ? ಫಸ್ಟ್ ಇದು ಏನಾಯ್ತು? ಲೂಸ್ ಆಯ್ತು. ನೆಕ್ಸ್ಟ್ ಏನಾಯ್ತು? ಗೈನ್ ಆಗಕ್ಕೆ ಶುರು ಆಯ್ತು. ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಲೂಸಿಂಗ್, ಇಟ್ ಸ್ಟಾರ್ಟೆಡ್ ಟು ಗೈನ್. ಸೊ ಅಕ್ರಾಸ್ ದ ಪೀರಿಯಡ್ ಏನಾಗುತ್ತೆ? ಇವಾಗ ಟೆಂಡೆನ್ಸಿ ಟು, ಸಿ ವಾಟ್ ಈಸ್ ಮೀನ್ ಬೈ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್? ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ದಟ್ ಟೆಂಡೆನ್ಸಿ ಟು ಗೈನ್ ಎಲೆಕ್ಟ್ರಾನ್. ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ, I'm talking about non-metallic character. Non-metallic character is nothing but tendency to gain electron. Okay, so ಏನಾಗ್ತಾ ಇದೆ ಇವಾಗ? You have observed that when we look at sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, ಏನಾಗ್ತಾ ಇದೆ? ಟೆಂಡೆನ್ಸಿ ಟು, ಓಕೆ, ಟೆಂಡೆನ್ಸಿ ಟು ಏನಾಗ್ತಾ ಇದೆ? Non-metallic character ಏನಾಗ್ತಾ ಇದೆ? Decrease ಆಗ್ತಾ ಇದೆ. Across the period ಏನಾಗ್ತಾ ಇದೆ? Decrease ಆಗ್ತಾ ಇದೆ. So non-metallic character is nothing but tendency to gain electron. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ? So are you clear with this concept? ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? Should I have to repeat this concept once again? Should I have to repeat this concept once again? Should I have to repeat this concept once again, children? So if you want, I'll repeat this once again. I think few did not understand. Okay. See, I'll tell you what happens to non-metallic character across the period. See, across the period, what happened? The non-metallic character will increase. Non-metallic character ಅಂದ್ರೆ ಏನು? Tendency to gain electron. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? Losing stop ಆಯ್ತು, gaining increase ಆಯ್ತು. See, across the period ಏನಾಗುತ್ತೆ? Non-metallic character increase ಆಗುತ್ತೆ. ಡೌನ್ ದ ಗ್ರೂಪ್ ಏನಾಗುತ್ತೆ? ನಾನ್ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಯಾಕೆ ಅಂದ್ರೆ ಸಿ ಸೋಡಿಯಂ, ಮೆಗ್ನೀಷಿಯಂ, ಅಲ್ಯೂಮಿನಿಯಂ, ಸಿಲಿಕಾನ್, ಸಲ್ಫರ್, ಫಾಸ್ಫರಸ್, ಕ್ಲೋರಿನ್, ಆರ್ಗನ್, ಇವಿಷ್ಟು ಎಲಿಮೆಂಟ್ಸ್ ನೋಡಿದಾಗ ಏನಾಗುತ್ತೆ? ಸೋಡಿಯಂ ಅಲ್ಲಿ 1 ಎಲೆಕ್ಟ್ರಾನ್ ಲೂಸ್ ಆಗುತ್ತೆ, ಮೆಗ್ನೀಷಿಯಂ ಅಲ್ಲಿ ಲೂಸ್ ಆಗುತ್ತೆ, ಅಲ್ಯೂಮಿನಿಯಂ ಅಲ್ಲಿ ಲೂಸ್ ಆಗುತ್ತೆ, ಸಿಲಿಕಾನ್ ಅಲ್ಲಿ ಲೂಸ್ ಆಗುತ್ತೆ, ಸಿಲಿಕಾನ್ ಅಲ್ಲಿ ಶೇರ್ ಆಗುತ್ತೆ, ಫಾಸ್ಫರ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? ಗೈನ್ ಆಗುತ್ತೆ, ಫಾಸ್ಫರಸ್ ಅಲ್ಲಿ ಗೈನ್ ಆಗುತ್ತೆ, ಸಲ್ಫರ್ ಅಲ್ಲಿ ಗೈನ್ ಆಗುತ್ತೆ, ಕ್ಲೋರಿನ್ ಅಲ್ಲೂ ಕೂಡ ಗೈನ್ ಆಗುತ್ತೆ. ಏನಾಗುತ್ತೆ? ಗೈನಿಂಗ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ. So across the period, electronegativity, which is nothing but the non-metallic character, will increase across the period. What about down the group? Down the group ಅಲ್ಲಿ ನೀವು ನೋಡಿದ್ರಿ, ಹೈಡ್ರೋಜನ್ ಇರಬಹುದು, ಲಿಥಿಯಂ ಇರಬಹುದು, ಪೊಟ್ಯಾಷಿಯಂ ಇರಬಹುದು, ಸೋಡಿಯಂ ಇರಬಹುದು, ಎಲ್ಲದಕ್ಕೂ ಕೂಡ ಒಂದೊಂದೇ ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ. ಸೊ ಏನಾಗುತ್ತೆ? ಇಲ್ಲಿ ಗೇನಿಂಗ್ ಇರಲ್ಲ. ಇಟ್ ಕ್ಯಾನ್ ಈಸಿಲಿ ಲೂಸ್ 1 ಎಲೆಕ್ಟ್ರಾನ್. ಸೊ ಡೌನ್ ದ ಗ್ರೂಪ್ ಏನಾಗ್ತಾ ಇದೆ? ಡೌನ್ ದ ಗ್ರೂಪ್, ವೆನ್ ವಿ ಲುಕ್ ಅಟ್ ಡೌನ್ ದ ಗ್ರೂಪ್, ನಾನ್ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ವಿಲ್ ಡಿಕ್ರೀಸ್. ಯಾಕೆಂದ್ರೆ ಈಸಿಯಾಗಿ 1 ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನ ಇದು ಲೂಸ್ ಮಾಡ್ಕೊಳ್ಬಹುದು. ಈಸಿಯಾಗಿ ಇದು 1 ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಲೂಸ್ ಮಾಡ್ಕೊಳ್ಬಹುದು. ಸೊ ಅಕ್ರಾಸ್ ದ ಪೀರಿಯಡ್ ನಾನ್ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ವಿಲ್ ಇನ್ಕ್ರೀಸ್, ಡೌನ್ ದ ಗ್ರೂಪ್ ನಾನ್ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ವಿಲ್ ಡಿಕ್ರೀಸ್. Very important. I think you all are clear with this concept. Do you have any doubt? Do you have any doubt? Do you have any doubt, dear students? Did you understand what is meant by metallic character and what is meant by non-metallic character? One thing you have to remember, metallic character is nothing but tendency to lose electron. Non-metallic character is nothing but the tendency to gain electron. ಅರ್ಥ ಆಗ್ತಿದೆಯಲ್ಲ? metallic character is nothing but tendency to lose electron. ಲೆಫ್ಟ್ ಇಂದ ರೈಟ್ ಗೆ ಹೋದ್ರೆ ಏನಾಗುತ್ತೆ? ಲೂಸಿಂಗ್ ಸ್ಟಾಪ್ ಆಗುತ್ತೆ. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಗೈನಿಂಗ್ ಶುರು ಆಗುತ್ತೆ. ಸೊ ನಾನ್ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಅಂದ್ರೆ ಏನು? ಟೆಂಡೆನ್ಸಿ ಟು ಲೂಸ್ ಎಲೆಕ್ಟ್ರಾನ್. ಸೊ ಲೆಫ್ಟ್ ಇಂದ ರೈಟ್ ಗೆ ಹೋದ್ರೆ ಏನಾಗುತ್ತೆ? ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಡಿಕ್ರೀಸಸ್. ಬಟ್ ಟಾಪ್ ಇಂದ ಬಾಟಮ್ ಗೆ ಹೋದ್ರೆ ಏನಾಗುತ್ತೆ? ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಇನ್ಕ್ರೀಸಸ್. ಅದೇ ನಾನ್ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಬಗ್ಗೆ ಮಾತಾಡೋದಾದ್ರೆ ಏನಾಗುತ್ತೆ? ಲೆಫ್ಟ್ ಇಂದ ರೈಟ್ ಗೆ ಹೋದ್ರೆ ನಾನ್ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಏನಾಗುತ್ತೆ? ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಗೈನಿಂಗ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಟಾಪ್ ಇಂದ ಬಾಟಮ್ ಗೆ ಬಂದ್ರೆ ಏನಾಗುತ್ತೆ? ಒಂದೊಂದೇ ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ ಫಸ್ಟ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ. ಸೆಕೆಂಡ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ನೋಡಿದ್ರೆ ಓನ್ಲಿ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ದೇರ್. ಸೊ ಏನಾಗುತ್ತೆ? ಇಲ್ಲಿ ಟಾಪ್ ಇಂದ ಬಾಟಮ್ ಗೆ ಬಂದ್ರೆ ನಾನ್ ಮೆಟಾಲಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ವಿಲ್ ಏನಾಗುತ್ತೆ? ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಬಿಕಾಸ್ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ಸೊ ಈಸಿಯಾಗಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಲೂಸ್ ಆಗುತ್ತೆ, ಗೈನ್ ಆಗಲ್ಲ, ಲೂಸ್ ಆಗುತ್ತೆ. ಎಸ್ ವೆರಿ ಗುಡ್ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್. So we have understood this. See, I told you that non-metals are electronegative as they tend to form the bonds by gaining the electrons. Non-metals occupies the right side of the periodic table. So I told you left side of in the periodic table, left side or there are metals are present, and in the right side the non-metals are present. Okay, and non-metals character increases across the period due to ineffective nuclear charge. That means tendency to gain electron increases. And non-metallic character decreases as we go down the group because ineffective nuclear charge experienced by the valence electrons, what happened? The tendency to gain electron decreases. Okay, so this is the one important thing. Ivishtun ಮಾತ್ರ ನೆನಪಿಟ್ಕೊಂಡ್ರು ಸಾಕು, ನಿಮ್ಮ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ನೀವು ಬರಿಬಹುದು. See, non-metallic character across the period increases, down the group decreases. Okay, so yes. See, in the middle of the periodic table we have the semi-metals. Semi-metals are also called as metalloids. Okay, and these metalloids, they exhibit the both properties of metals and non-metals. Why do we call it as metalloids or why do we call it as semi-metals? Because they exhibit both the properties of metals and non-metals. And most importantly, you want to understand, dear students, see, oxides of the metals are basic in nature because in the acids, bases, some salts, and also the metals and non-metals lesson I have explained. Okay, metallic oxides are basic in nature. That is the same thing which we are repeating here. Okay, oxides of metals are basic in nature, whereas oxides of non-metals, that means non-metallic oxides are acidic in nature. Very important. Metallic oxides are basic in nature, non-metallic oxides are acidic in nature. So these are the very important things. Okay. Why inert gases are kept in the 18th group, somebody is asking. See, because inert gases are completely filled shell, dear student. See, when we look at the inert gas, they are all present in the 18th group. When we look at their outermost shell, all the outermost shell except helium. Helium is satisfied by only having the 2 valence electron at the outermost orbit. When we look at the outermost shell, helium, see, helium is having 2 valence electron. By having only 2 valence electron, it is completely, filled. When we look at the next element in the periodic table, that is in the 18th group, okay, neon is there. So neon's electronic configuration is 2,8. Okay. When it comes to next element, that is the argon, the argon's electronic configuration is 2,8,8. See, if you look at here, so everywhere in the outermost orbit here, 8 valence electrons are there. 8 valence electrons means they are stable. So the valency here is 0. Valency here is 0. Valence electrons are 8. They are completely stable. As they are completely stable, they are called as inert gases. They are completely stable, so they are called as inert gases. Okay, yes. See, I am not deleting any video every day. See, please understand. See, as it is a live video, okay, so this will be, saved in the YouTube channel after 24 hours, okay, or almost after 18 hours to between 24 hours, it will be there. So fine, I will share the link of this in Telegram, okay. I don't delete any videos after the live is completed, dear student. Once the live is completed, a video will be there. But as it is not a recorded video, as it is directly live, it will be not shown in the channel video list for 24 hours. After 24 hours, you can find the same video in the in my video section. Okay. Yes. Yes. I think you're able to understand this. Okay. So everybody is clear about this concept, children. Do you have any doubt? Do you have any doubt in this particular concept? Do you have any doubt, dear students? If you have any doubt, if you don't know what is meant by atomic size or metallic character, non-metallic character, I would like to say you once again. Okay, if you want me to explain any concept, if you don't know any concept in this lesson, ask me now. Tomorrow we will be discussing the question answers. Do you have any doubt? If you don't have any doubt, I can end the live. Yes. Fine. So very good, students. I think you don't have any doubt. Okay. So notes of sources of energy. Yes, I will share now. Okay. After 7:15, I will share. So somebody is asking about atomic size. I already told you what happens to atomic size. See, once last time I'll explain you what will happen to atomic size. See, dear students, when we move from left to right, atomic size decreases. But when we move from top to bottom, atomic size increases. Why it decreases? Why it increases? Because when we move from left to right, what happened? The number of valence electron increases. See, for example, when we take the second period, let us take second period this time. So lithium is having 2,1 as the electronic configuration. Lithium, after lithium, the fourth elements, hydrogen, helium, lithium, beryllium. Beryllium is having 2,2. So then beryllium afterwards we have boron. Okay, 2,3. So after boron we have hydrogen, helium, lithium, beryllium, boron, carbon. We have 2,4. So what are you observing here? You are observing the number of valence electron is increasing. As the number of valence electrons are increasing, the attraction between the nucleus and outermost orbits electron increases. So nuclear force increases. As the nuclear force increases, what happened? When we move from left to right, what happened? The atomic size decreases. As the atomic size decreases, we say that across the period atomic size decreases, but top to bottom atomic size increases, because on the first, hydrogen is having only one shell. When it comes to lithium, lithium is having the 2 shell. When it comes to sodium, sodium will be having 3 shells. So when we look at the group wise from top to bottom, the number of shells increasing. As the number of shells are increasing, what happens? The atomic size is also increasing. Okay? Yes. So please learn. I told you know the elements. I told you some 20 elements, how to learn those 20 elements. So without forgetting those 20 elements, please understand and you have to learn. So if you don't know how to learn 20 elements, one easy trick video has been posted. If you want, I'll post it in Telegram group now. Those who are in the Telegram group, for them I'll post it. And you can also learn 20 elements writing. Very importantly, you want to write it. Okay. So that's all for today's class, my dear students. I hope you have understood entirely about the periodic classification of elements. So ನೀವೇನೇನು ಇಂಪಾರ್ಟೆಂಟ್ ಕಲ್ತ್ಕೊಳ್ಬೇಕು ಅಂದ್ರೆ 4 laws ಕಲ್ತ್ಕೊಳ್ಬೇಕು. ಸೊ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿ ಒಂದು ಗ್ಲಾನ್ಸ್ ಅಪ್ ಮಾಡ್ತೀನಿ ನೋಡಿ, ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಫ್ರಮ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಲೆಸನ್ ಏನು. ಸೊ ಫಸ್ಟ್ ನೀವು ಮರೀದೆ ಏನ್ ಕಲ್ತ್ಕೊಳ್ಬೇಕು ಎಕ್ಸಾಮ್ಗೆ ಅಂತಂದ್ರೆ, ಯು ಹ್ಯಾವ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ 4 laws ಕಲ್ತ್ಕೊಳ್ಬೇಕು. ಲಿಮಿಟೇಷನ್ಸ್ ಆಫ್ Newlands periodic table and also Mendeleev's periodic table, 2 limitations ಕಲ್ತ್ಕೊಳ್ಬೇಕು. ಅದನ್ನ ನಾವು ಡಿಸ್ಅಡ್ವಾಂಟೇಜಸ್ ಅಂತ ಕೂಡ ಹೇಳ್ಬೋದು. And you also have to learn about the merits or advantages of the Mendeleev's periodic table. You have to learn. And you have to learn about what is meant by atomic size. You have to learn the trends in modern periodic table. Trends, we have learned about valency, we have learned about valence electron, atomic size, so and also metallic character, non-metallic character. These are the very important points from this particular lesson. So ಇಷ್ಟು ಗೊತ್ತಿದ್ರೆ ನಿಮ್ಗೆ ಎಲ್ಲಾನು ಗೊತ್ತಿರುತ್ತೆ. ಇಷ್ಟು ಗೊತ್ತಿದ್ರೆ ನಿಮ್ಗೆ ಎಲ್ಲಾನು ಗೊತ್ತಿರುತ್ತೆ. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ? So clear. So that's all for today's session, children. Thanks for being in live till now. So have a happy day. So concentrate on other subjects also. So if you are going to school, listen to what your teacher is saying. So understand, practice more on which concepts you are not able to get easily answered. ಯಾವ್ದು ನಿಮಗೆ ಕಷ್ಟ ಆಗ್ತಿದೆ ಅದನ್ನ ಫ್ರೀಕ್ವೆಂಟ್ ಆಗಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. ಸೊ ಇವತ್ತಿಗೆ ಎಕ್ಸಾಕ್ಟ್ಲಿ 8 days ಇದೆ ಫಾರ್ ಯುವರ್ ಫಸ್ಟ್ ಎಕ್ಸಾಮಿನೇಷನ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಮಂಡೇ by this time you will be having first examination of your public, the board examination. So all the best for you all. Take care. So see you all in the few more videos. ಇವತ್ತಿನ ಈವ್ನಿಂಗ್ ಅಲ್ಲಿ ನಾನು ಪ್ರೇರಣಾ ಪೇಪರ್ 3 ಅಪ್ಲೋಡ್ ಮಾಡ್ತೀನಿ. ಪ್ರೇರಣಾ ಪೇಪರ್ 1 ಅಂಡ್ ಪ್ರೇರಣಾ ಪೇಪರ್ 2 ನ ಅಪ್ಲೋಡ್ ಮಾಡಿದೀನಿ ನಾನು ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ಫಾರ್ ಎಕ್ಸಾಮಿನೇಷನ್ ಪ್ರಿಪರೇಷನ್. ಸೊ ಪ್ರೇರಣಾ ಪೇಪರ್ 1, 2, 3 ಈ 3 ಕ್ವಶನ್ ಪೇಪರ್ ಕೂಡ ಒಂದ್ಸತಿ ಥರವಾಗಿ ಸಾಲ್ವ್ ಮಾಡಿ. ಫ್ಯೂ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ವಿಲ್ ಕಮ್ ಫಾರ್ ಎಕ್ಸಾಮಿನೇಷನ್ ಫ್ರಮ್ ದಿಸ್ ಪೇಪರ್. ಓಕೆನಾ? ಸೊ ಪ್ರೇರಣಾ ಪೇಪರ್ 3 ನ ಇವತ್ತು ನಾನು ಅಪ್ಲೋಡ್ ಮಾಡ್ತೀನಿ. ಓಕೆನಾ? ಸೊ ಅದಾದ್ಮೇಲೆ ಟುಮಾರೋ ಮಾರ್ನಿಂಗ್ ಯು ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ದ live session for the questions based on the periodic classification of elements. That's all. Thank you so much, children. Have a nice day.